Ja.
Ich werde mich auch einloggen.
Is this our Zoom?
Start again with, I particularly want to start again with a fact that this day 1, day 2, day 3 will be recorded. It's being recorded. I saw the recordings yesterday myself, so they're there, they're on the cloud. We will upload them. And today is also fully recorded, so you can access them. So don't be tense that you miss anything, because you really won't. We had overview of team dynamics yesterday. We looked at the Envision data set and got some overview on multimodal signal processing. And we did a very fast introduction into video motion tracking, and then went into multimodal data analysis. We ended yesterday with a guest lecture by Professor DeMello on deep learning, AI, and machine learning. And we wrapped up with some general questions, some areas that we want to intensify, maybe collaboration throughout the bootcamp and after. Today is also equally exciting and interesting. So the first part of the day is still hands-on and intense, and you can follow, and the recordings are also available. We start with Open Face by James Trujillo. Kinematic features comes next at 10:45 to 11:15. Then we have a coffee break, tea break, water break, and then we go into gesture networks by Wim. We will then follow that with a lunch break, very short, 45 minutes from 12:30 to 13:15. This is like German time, but if questions follow and lag and lead, it might be flexible a bit. But this is what we have on paper, just for structure. Then we go into the multivariate module by Wim and James. Then a short coffee break, and then we have our guest lecture by Fronzetti Colladon and Signeri. So really, really packed day, really also equally exciting. We have snow here in the background. We're looking outside and it's very, very snowy. And we hope that your environment right now is as refreshing and calming and good enough that you enjoy Envision Bootcamp Day 2. Ola, did I miss anything?
Maybe for the cameras, if people can.
Yeah, so we would love to really, really see your lovely faces from all over. Just maybe shortly. It also helps with the speaker to know that people are there. So if you can just show your video, put it on for a while, that could be really good. Thank you. I just want to also announce again quickly. So it's a lot. There's the GitHub page. We expect that you're looking less now at one thing, where you're no longer looking a lot at the website, but you can pay some more attention to the Miro board. So please put your challenges there. So we have day 2 on the Miro board. I hope you have no challenges getting in there. Day 2 in the Miro board. It's quite easy. Just type in your name, your task, which university you're from, and just questions you have throughout the event, so that we can get a sense. It's a bit like a thermometer for us to know, okay, many people have these themes that they're kind of struggling with, and we can engage you better with that. So you can please use the Miro board and in combination with following the bootcamp. That's all from my side. Very warm welcome again from the host from here in Potsdam. We wish you a very nice second day. Now off to James.
All right, so welcome back everyone. Day 2. So we're gonna start out indeed with Open Face. So I'm going to go ahead and start sharing my screen now. Right, so everyone should now be able to see the screen here. So just to give you a bit of an introduction to what this day is going to be and what the modules are going to be like. Yesterday was this kind of fast-paced introduction to motion tracking and kind of looking at how we can apply these different methods to actually get some data. And today what I want to do is provide some basically starting points for analyses. So we call these the kind of analysis modules. We set some things up, It's not the sense that we're trying to provide a full run through of a study where we say these are very like tested hypotheses or something, but more to set you up to see how you can quantify information in a useful way that you can start answering some questions. So I'm going to use as a kind of case example for our open face, looking at this kind of multimodal prosody example. So we're going to do just a little short analysis looking at the relationship between eyebrow movement and speech, and basically see if there's some sort of temporal relationship there. And this isn't something that I just came up with out of the blue necessarily. There are some studies that have shown a correlation here, just like we've seen examples of, for example, speech gesture prosody with the hands, where there's this temporal relationship between the peak velocity of a hand movement while you're gesturing and your speech. There's also been some studies suggesting the same kind of thing happens with the eyebrows, that you can use your face essentially to signal emphasis or prosody. So that's what we're going to do as a kind of starting point. Like I said, this is not to try to show some super novel study or something like that, but just to kind of get you an idea of how you can use this motion tracking data for your own purposes. So what we're going to use is the open face data that we talked about yesterday. I'm going to also use Seaborn as a way of plotting in Python. And we're also going to use a package called Parcelmouth. You can install that using pip install and then prat Parcelmouth. And essentially what this package does, if you're familiar working with speech data and you've used the program prat before, this is essentially a Python interpretation of that. So it calls on that and uses that, but then all via Python. And if you're like me and you don't like learning all of these other different kind of programs and languages and you just want to do everything in Python, this is fantastic. So that's what we're going to use today for this. So starting out with this first block, we basically just want to load in our file. Very simple, nothing too crazy there. We're using Exploface to get the features. This is something that I mentioned yesterday as well. And just to give you a little bit of context on this, we're going to be using a time series, essentially the open face data from the Saga corpus. This is the Bielefeld speech and gesture alignment corpus. So we're just going to use one kind of bit of this as a case example. The reason is that this is just essentially, we have video data of someone who is speaking throughout, and we also have some kind of nice annotations that we can use so we make sure that we're actually looking at something interesting. So for example, either sentences or words or whatever, and then we can use this to kind of create the alignment for our little project. So the first bit, before going into the actual analyses, we talked about this a couple of different times yesterday. Smoothing is really important for your data. And so I put this part in just to kind of show an example of that. I'm using matplotlib here as a simple way of plotting. And essentially what we're going to do is I'm just going to take one of these features, and we're going to plot a small subsection of it just to kind of show you the difference between the raw data and the smooth data. And for this, I use the Savitsky-Golay filter. And you can already kind of see here with the raw data and the smooth data, the point that I want to get at here is that you can see overall the same kind of features are present in the smooth data as the raw data. So this filtering that's been performed on it hasn't really stripped away the actual kind of shape of the time series per se, but you can see that this little bit of jitter throughout. If you look at this kind of second peak here, you have this kind of jitter on the raw data, and this is smooth to just one kind of nice curve on the second one. So this is the way that I usually approach smoothing with these things. You want to get this kind of this natural jitter that you get from motion tracking. You want to strip this out a bit, but you do want to keep the overall shape. So that seems to be successful. The reason I show this is really just to give you an idea of how you might want to do this, approach it with your own data, is to just do this kind of plotting and see how the smoothing works out for you. So in this next bit, see if I can zoom back out a bit. Yeah. So for this next bit, we're going to start calculating the movement of a visual articulator. So, like I mentioned before, this is going to be about eyebrows because we have this. We have some evidence that this is something that's interesting or relevant for prosody. But of course, the kind of difficulty here in this kind of data is that it's not that you have a static kind of just face that's centered and not moving and the eyebrow perfectly moving around in space. You of course have the head that's also moving around in the frame. It could be tilting, it could be shifting side to side. And so what you really are interested in is not necessarily the kind of raw movement of the eyebrow per se on the screen. You want it in relationship to where it was or where it was on the face. So that's what we're going to try to do here is do a couple of little tricks in order to try to get a kind of relative position or relative movement of the eyebrow on the face. So what I'm doing in these first couple of blocks is essentially just taking from our data frame that has all of these different features going across the X and Y values. And we're first just going to use list comprehension, and we're going to grab these features that we want, the X and the Y values that specifically relate to a point on the left eyebrow, a point on the right eyebrow. And we're also going to rename them so that we don't have to kind of think about what the actual landmark name is every time. So rather than having our values or our column names being X24, X19, we're just going to say, okay, this X24 is going to be X, Y24 is going to be Y. And by doing that across both of them, now we have this nice frame where we simply have two different data frames, one for the left, one for the right. And in both cases, they just have an X column and a Y column. So this is a lot easier for doing calculations because we know what it's relating to because it's one data frame. Besides this, besides the eyebrows we're really interested in, we're going to take the nose. So in this case, if you remember back on the open face module, so I'll switch to this tab here. We have several points on the nose. We have this center point, which is kind of a nice static point on the face, but we also have several others that we can kind of assume shouldn't move around too much. Even if you kind of crinkle your nose a bit, these kind of central points shouldn't change too much in position. So we're going to take advantage of that. We're going to go ahead and grab this central point. So we're going to have that as well. And then we're going to have these, what I call the nose fixed points. So this is 32 and 34. So if we look, this is essentially just right on the left and right on the right of this central point on the nose. So these are things I think they're going to be relatively fixed, but they are distant from one another. So this will be important. So then we get into this function where I'm going to calculate the velocity. So essentially taking the change in movement of our time series that we're interested in. And we're going to try to get this in context. So first of all, we want to get the relative position. So assuming we were to feed this, this function, for example, the time series that is the left eyebrow, we would, again, use list comprehension here. We're going to effectively loop through our time series, in this case, the left eyebrow values. And then for each X value in a given row, we're going to subtract the nose value on that same row. So essentially what we're saying is rather than the position of the eyebrow on the screen, we're now just saying what is its position relative to the nose value. So very simple, basically just trying to kind of center this in our frame. After that, we now need to calculate the actual displacement and the velocity. So again, we're going to loop through our whole time series. And first, we're going to calculate displacement. So this is just kind of a simple mathematical formula, essentially taking for each XY pair, going through it and seeing what is the displacement or essentially the Euclidean distance between one point and the previous point. So how much has it moved? I remember this is also in relation to the nose. So if the head moved around a little bit, this also shouldn't change too much because we're considering this kind of distance. And basically the point is the distance between the nose and a starting point on the eyebrow should be relatively stable. But if you raise your eyebrows, then this will change that distance. Yeah, so now we have this. This should be kind of correcting for most kind of normal movements that you would expect, just changing around, assuming the person is sitting very still. The other thing that we want to take into consideration is the fact that the person might not be perfectly stable in relation to the camera. And so I was happy to see, I think someone put this in one of their challenges that they're asking about this, this kind of problem of distance to the camera. Because these motion tracking values are in pixels, it can be a bit difficult because if the person moves forward or back, then of course already the distance between, for example, the nose and the eyebrow is also going to change. It's going to get much bigger because it's taking up more space on the camera frame, essentially. So what we're going to do is first calculate the distance between two fixed points. So this is why we have these two points on the nose, these two on the side. It doesn't actually matter too much which ones they are, just that they are fixed. They're not going to change in position with different facial expressions or anything like this. It's really just going to be a fairly stable calculation. And then what we're going to do is take our displacement that we've calculated for this frame, and we're going to divide it by this fixed position. And so effectively what this does is you now have a change in position, so this kind of Euclidean distance, but then we're always dividing it by something that we know should not change. So if the person moves closer to the camera, then this fixed distance value will essentially go up, and then we'll be dividing by a larger number, and thereby also kind of correcting for this kind of change. So these are just a couple of kind of simple tricks to take into consideration these different things, and this should kind of work out any kind of movements that the person is making on the screen, at least anything that we can correct for in this kind of way. So after we have the displacement, we can calculate the velocity. So now we're just simply taking this displacement value and multiplying it by the frames per second. Because you can imagine if, for example, something moves by, we'll say for an easy calculation, 1 meter in one frame, then of course, if you're running this at 25 frames per second, that means that the velocity at that point, the momentary velocity, is going to be 25 meters per second. So that's what we're going to be getting here. And then like we talked about, it's important to do this smoothing. So after we've calculated the velocity, we're just going to apply this kind of simple Savitsky-Golay filter again, just to smooth out any wrinkles in the velocity time series. And so while we calculate both displacement and velocity, both can be interesting, but effectively for this type of analysis, we're just going to stick to the velocity calculation and use this going forward. So this is what we do. So we've just defined this, this function here. And then now in this next block, we actually calculate them. So you can see, for example, in the smoothed left eyebrow values, we go ahead and feed it the left eyebrow time series. We give it the nose value in order to do that first calculation, and then the two fixed values for the second, and then we give it its the frames per second. So this is something that's built in there just so you can check with your own videos. Typically they are 25 or 30, but it is good to kind of check for yourself. If you know you're only working with one, of course you can simplify this and strip this out and just hard code it. I like to leave it in just in case I'm moving between different types of videos, but for the Saga corpus, the 25 is what we needed. So going into the next bit, here we're going to start working with annotations. We're going to start working with the actual audio files. So what we'll do here is we're going to, again, take this annotation file that I mentioned. So now we have kind of an idea of where in this file people are doing what. We're going to get the timestamps because we're going to be using those as well. And we're going to take the audio file. So since we're working with prosody, we of course need to calculate some acoustic features. So what we're going to do in this loop is simply go through this annotation file, annotation by annotation. For the purpose of this, I didn't want to go too much into some sort of hypothesis testing like I mentioned. So I'm basically just going through an annotation that's giving sentences, I believe, in this case. And we're just going to try to find the peak values for the eyebrow and for speech and see if there's any kind of alignment at this sentence level. Of course, for your own analyses, you should probably specify this more, but this is just to get you started. So what we'll do, this is all kind of very simple, but it's a nice framework to start with. We're going to take from each of these annotations the starting time and the ending time, getting some timestamps from that. And using that, we're going to use this parcel mouth library, and we're going to extract the sound bit, essentially, that corresponds to this annotation. We also want to, of course, get the eyebrow. So we'll also make sure we have the timestamp values that correspond to this. So the kind of important thing here is that for the sound file, we're going to be calculating this actually in seconds. And then for the motion tracking, we want to have this in frames. So this is just for kind of some simple calculations. And then using parcel mouth, essentially Pratt, we're going to get the pitch values. These are just some kind of standard set values for having the low and high for the pitch and kind of how it's going to be divided up. You can, of course, change this as needed. And then we're going to get the timestamps. So essentially what this is, because this is one sound file or one block, these timestamps are going to tell you the actual kind of relative distance between the different values that you have, but it's not going to be actually set in the annotation time. So that's why we then, using the annotation time, then go ahead and add this back on. So you can imagine that if the annotation started at 1 second into the video, your first kind of calculations are going to still start from about 0. That's not very helpful. So knowing that it starts at 1, we simply add these back on, and now we have the actual relative timestamps for this. This next bit, also just kind of simple calculation. This is how we tell Python that we want to extract the pitch tier from this file. And then we make it into a list. So this is, again, just for kind of easy Python calculations. And then we want to be able to get the eyebrow movements. So we first take a subset of the data. So this, again, just kind of making sure we know where things start, where things end. And then now, since we have this smooth velocity data frame for the 2 eyebrows, we can now use these indices that we've created and just take a slice of this and say these are essentially the motion tracking values, the velocity points that correspond to the annotation, for which we also have the pitch values. And then again, it's very simple. We're simply going to take the maximum value. We're going to make sure that we have the index of that value so we know when it happens, so we can get the timestamp. This is why we need those actual timestamps that are relevant or relative to the whole video, so we know how they correspond to one another. And so in this way, this kind of goes around this issue of the fact that the sound file has a fairly different sampling rate than the motion tracking, because they are going to be different at this point. But then if we just take the actual value and just say, okay, at what point? So here we see we're taking this location, we're grabbing the timestamp, and we're just saying what is the actual numerical time that the maximum eyebrow movement or velocity occurs. And we do this again for the pitch as well. And we're essentially just going to, by having our annot file here, we can just add these values in so that we know for each annotation, we also have these values. So I'm going to just run through this so we can make sure everything is there and we can see what this actually looks like. I hope I don't upset Python by trying to go through all of it too quickly. Probably will. But I think it's good to kind of see what these different values actually will look like when we plot them out. So we'll just quickly do all these calculations and wait for that to run. And basically the idea is that we should now have a pretty orderly data frame that we can do these kinds of calculations on. And you can imagine that with this kind of structure, now I've just given it the left and right eyebrow time series to work with, but you could also do any other point in the face. You could also do some kind of calculation, for example, looking at the maximum mouth opening, again, doing some kind of simple mathematical calculations for the area of the opening. You could look at squinting or any other kind of actions as well. So that would all be quite fine. So here we'll run this.
I suppose you could add them up too, meaning this one plus this one translates to happiness or whatever they.
Yeah, exactly. Yeah, if you had some kind of cluster, you could indeed kind of see if these things are happening or how they kind of align with one another. If you had multiple, you could also just get something categorical, for example, to say, is there a cluster of more than 3 with more than this value, and just see, is this something that we're interested in, indeed. So here, just to give a kind of quick example of what our data looks like now. So here you can see we have the beginning time, the end time in milliseconds. We have our annotations that we were given, for example, the sentence. We have our pitch peak value, so this is just the highest pitch that was recorded there. We have the actual time that this happened. We have the movement or the velocity of the eyebrows. We have the timing of those. Notice that they're both in seconds, so we know that they're actually being aligned. And then what we calculated here at the end, this last little bit, by looking at the brow time, the pitch peak time, we now also know what the difference, the timing difference is between the peak in the eyebrow and the peak in the pitch. So this is just basically to get this one kind of value that we can now look at and see, is this kind of tightly aligned or is it really just all over the place? So now we have everything we need in order to do this kind of plotting. So for this, we're going to, like I said, use Seaborn, and we're just going to do a couple of plots on here. And we'll get some warnings because I'm using deprecated packages, but, well, I couldn't, or I didn't really want to look up the new versions. Sorry, you can do that yourself as homework. But essentially, these still work. So we get, essentially, these are the distributions, and they'll still at least work with this package. But what we're looking at here is the kind of distribution of offsets. And the kind of hypothesis that we would have is that if these two signals are being aligned with one another, then we should see a kind of tight coupling between the two, and they should be kind of peaking around 0. And this is exactly what we see for both the left and the right eyebrow. We see that most of this density is indeed kind of clustering right around 0. So we do have a lot of variation in this, of course. This could also be because this is a fairly underspecified analysis in the sense that we're just taking sentences and just kind of checking. But even this kind of quick and dirty approach to it, you see that the mean offset between the two of them is right around 200 milliseconds, which is about what we would expect for this kind of prosodic coupling. So this, I think, is kind of a nice, simple way to do things. Yeah, I didn't want to go too much into these different types of, because you can go in so many different directions in terms of if we want to do categorical analyses, numerical, continuous analyses. But just to give you kind of a taste of what you can do by having this this motion tracking data of the face, and then leveraging this just for some kind of visual signaling to see how is this changing in relation to some other signal, in this case, the acoustics. The last little bit, yeah, it's not a whole lot of explanation to go on, but basically just as a little bonus thing for you, for people who have essentially just a video file and not a video and an audio file, I want to include this as kind of a useful quick trick that is definitely I've used many, many, many times. And this, if you have MoviePy installed, you can use this FFmpeg extract audio. And this is just a quick and easy way to extract the MP3 file from the video file. And you have these as well, and then you can easily run these parcel mouth based analyses. So this is, yeah, this was my open face analysis. So I think before I move on to the next one, because we do have some time, see if there are any questions so far. So I will check the chat, and hopefully I can keep track of both things at once.
James, I have a question right away.
Oh, great, great.
So I was wondering, say you have piercings. Mm-hmm. How does the open face track when somebody has piercings? Does it disturb it in any way, or?
Yeah, it's actually a really good question. As far as I have seen, it doesn't actually get too disrupted by this. It does
That's
quite
great
fine.
Compared to other motion tracking with where you have the markers that would reflect light.
Exactly. And this is definitely a problem with the optical systems. Indeed, that anything you wear, even if it doesn't look reflective to you, the marker or the tracking system will pick it up. But luckily, that's one advantage of these kind of more video-based ones, in the sense that it's just trying to recognize a face. It doesn't care too much about the details on it, as long as it can see the features. So if you have glasses on or anything kind of around your eyes, for example, I was also thinking of like makeup or mascara or something can mess up eye trackers, for example. But in this case, for this kind of motion tracking, it can see your eyes, it can see the general features, then it's fine. If you have piercings, it's also fine. Yeah, that definitely helps. Yeah.
Yeah. I'm wondering about kind of reversing these things. Just say I saw something in the video, and for me, looking at this, we have a fairly good correspondence between right and left, but then there's the arched eyebrow thing, which I can't really do, but people do. I'm wondering if there's a way of, when you look at the video, you can mark the video and then see what that looks like as a pair of waveforms, and then be able to write a little piece of code that's going to go. It's the arched eyebrow thing, rather than. Do you see what I'm saying? That is, it might be easier to do that by eye, to say, these are the moments. What are their characteristics?
Yeah, it's a good point in terms of this. We can't just take it all to be one thing, right? And I think that's, in general, has been my approach to figure out how to classify some of these things, is that indeed, if you mark some things manually and just say this is it, and you look at those waveforms, those kind of velocity or displacement plots, and see if there's something there. And I can imagine in this case, for this one, I really focus on the velocity profiles. But if you were to just do the raw positioning, or even the relative positioning relative to the nodes, for example, then you should be able to see that in that case, one of the relative positions should stay relatively stable, the other one should peak.
Right.
And then in those cases, you can kind of pull this out and say, this is actually this kind of facial signal.
How would you go about doing that? I can see actually using paper and pen, or pencil probably, and writing down at 3 minutes, 32 seconds, point X, there's something I want to look at, and then go back and look through.
Yeah.
Or is there a more kind of code-based way of,
It's always the question of how accurate it's going to be, and that will be a bit related to the quality of the tracking, the video, etc. But what you can do, for example, is, and I'll go into this a bit in the body-based tracking, is you can find these peaks. I think Wim also talked about it yesterday, this peak finding then for acoustics. And if you find then a peak, let's say in the eyebrow positioning or displacement, you can then find the beginning of the slope upwards, you can find the end of the slope downwards, and then you can just say, for this moment, for this time window, what does the other eyebrow look like? Is this kind of sub-threshold movement? If yes, then we have just one. If it's two, then we could even say, well, then we have some kind of classification of the double eyebrow movement. So there are definitely ways to kind of algorithmically kind of hard code, in a way, check these things. Yeah. Sometimes it works, sometimes it's not quite accurate enough, and you usually have to indeed kind of manually check a couple things and see what those thresholds should be, for example.
So when I used VCode, which is none of this sophistication whatsoever, it's just a video markup system basically, we were able to generate places with marks into a CSV file. I'm wondering if there's a way of then integrating the CSV, a tool like that, into the workflow, so I can visually have things, and the time code comes out, a mark comes out, and then I can compare that mark with the time code.
So you're thinking for generating these plots based on kind of manual annotations, in a way?
Yeah, purely visual annotations, but without having to write it down and then go, okay, let me find this back in it. It just would stick it into the notes and annotations on the waveforms.
Yeah, I mean, you can do something similar to where here I have the annotations just based on essentially what the person's doing or saying. You could have a similar type of thing if you have this kind of output for onsets and offsets of anything. It could be a visual signal, and then you could say, well, I'm actually really interested in what's happening when people raise their eyebrows or do this particular thing.
Right.
Let's extract those, let's see what's happening there. And you can calculate any kind of number of features based on that.
Cool.
Yeah.
Thank you.
Yeah, no problem. Yes?
Thanks for this,
James. My question is about accuracy again. So does the number of points that you track in the face affect the accuracy at all? Or if you track more things, then does the accuracy drop? Or
in general, or for this analysis?
In general, or for this analysis too?
In general, the analysis will be what it is. So OpenFace essentially has one option in terms of number of points that it tracks. You run it and it does its thing, and that's what you get, effectively. You can change the resolution of the tracking quality itself. You can at least lower it as a kind of speed accuracy trade-off. That's one thing. but you don't really change the number of points that are tracked, per
It
se.
doesn't create any kind of confusion.
No. No, and for this kind of thing, in terms of the analysis, the only thing I can imagine that would really kind of change in terms of points is you can always leverage more, like I'm doing here, to kind of pinpoint your time series or your relative position or what's happening based on what's happening with the rest of the face, essentially. So also thinking about this position in relation to the nose, but you could also say, well, actually, I should also take into consideration the other eyebrow, because if you kind of like raise it really far out or something. So these kinds of things you can always use a bit more, but you always have all the data. Yeah.
Thank you.
Yes.
So we have a question in the chat.
Yes.
I'll just read them.
Okay,
That's
great.
it. So first question is, how would you analyze, for example, eyebrow movements over time statistically? Would you use GAMS or other statistical modeling?
So that's I think the option is always up to you as a researcher in terms of what's the most interesting, I guess, because you can look at the variation over time, you can look at the peak, let's say the peak velocity at certain points, you can see if things are changing, if it's more variable or more peaked during different events. I think this is a very, very open kind of thing in terms of what you want to do with it. Because here I just show the timing of the peak, but you could also look at the peak value itself. You could look at what it's doing in relation to other signals. Yeah, so I wouldn't necessarily zoom in on any of those per se. It would be really about the research question. Yeah.
Okay, thank you. Just say that was a question from Marjana Ruiz. Now we have two more.
Okay.
Malin Spaniel is asking, could you explain again how you got the starting and endpoints for calculating each difference? Is it calculated for each frame?
Starting at endpoints for each difference. Is this let's see what kind of difference. So if we're looking at the velocity, for example, these differences, basically what it starts with, I'm just going to assume this is what it's about. This displacement is indeed from frame to frame. So it starts out in Pythonic numbering, it starts out on frame 1, and then you see what the difference is in frame 1 compared to frame 0, and then frame 2 compared to frame 1. And this is essentially just that displacement over time. Yeah, and then it's indeed that's done for each frame, and then we just do that for the annotation. So we just have a time series for each annotation.
Thank you, Malin, also. Thanks. And we have one more question. Maybe we have one in the audience.
If they also want to unmute themselves.
Yeah, you can also unmute yourself and just ask for next time. But I'll just read it out. Gregor Kahel is asking, I can imagine that extracting emotions is very tricky, but is there a way of using variation in the movement of facial points to create a proxy of facial expressiveness?
A very interesting question. I would guess I would maybe be a bit careful in this answer and say I assume there are ways to calculate something that people would approximate with this. If this truly relates to emotion, I always find a bit difficult to say, partially because, and this also something recently discussed here as well, because your emotion will also be a bit relative to your ecology, your environment, what the other person's doing, what you're doing. It can be kind of false emotions. It can be these kind of or false signals, I should say. So you can probably get things that are kind of classically kind of attuned to or correlate with emotion expressions, but also it depends a bit on how fine-grained you want that to be. So I think my kind of careful answer would be, I think you can probably get something from this because you have the values across the whole face, but I think it's very complex, and if that truly relates to human emotion is always a bit tricky, I would say.
If I can catch up on this, but if we're not interested in emotions per se, but for example, maybe a kindergarten teacher might be talking to a child, and in order to be very engaging, she's like, whoa, like using her face a lot, whereas somebody else might not do it. So if we're not interested in emotions, but rather just like, are you using your face to express something? Is that something we can get out of it? Like, my aim is not to get at emotions, but rather like, are you looking like Batman when you're talking with a child, for example, or are you looking like I don't know, Jim Carrey, like, wow.
No, this
Mine.
is fantastic actually. So this is, I'm going to go a bit into this on the kind of framing of the next bit, the kinematics. It's something that I find super interesting how you do this, because in gesture research we have this idea of child-directed action. You also have it in language, of course, with child-directed speech. And this is something that I've worked on, not in child-directed, but in general, kind of expressing or trying to signal your intentions by exaggerating the kinematics of your gestures, your movements. And so I would definitely say in terms of the face, you could do the same thing. So if you have some idea of what someone's doing, you can also see indeed how exaggerated are these features in terms of, so the mouth opening, the rate of lip movement. You could also see if someone really kind of slows down and makes these kind of exaggerated pauses as they produce their utterance, if they make large eyebrow movements. So we've also done this a bit, actually didn't even think to put this in here. We've done a bit of this kind of facial tracking in relation to people speaking in noisy environments. And we found that besides changing their gesture kinematics in order to compensate for a lot of background noise, they also, well, we focused in that case on the lips, but we see that they produce kind of these larger, faster, more segmented movements with their mouth. So essentially they kind of over-articulate as well. So this is something that, you know, in this case, we had a kind of more specific hypothesis about the mouth per se, but you could do the same for the eyebrows or for any other feature. And I think that would be something you could get out as long as you have some kind of idea of where to start from, because you have to have a baseline.
Talking to foreigners.
Yes.
One, right? Do you hear me?
Exactly, exactly.
There's something here. You guys, both you and Wim, are come back to velocity frequently. And I'm an engineer, so I know a little bit about velocity, but I want to know why it's a focus for you guys, because I would have been thinking distance, beat, something, but yesterday I started going, oh, velocity. And certainly in music, velocity is incredibly important, right? But can you say more about, I mean, it seems like that's a center for you, come back to velocity. Is that true, or?
So I think, at least from my point, velocity is a starting point for most of these things, because it's a way to capture the kind of most basic aspect of movement in that sense, especially when you're looking at the timing of things and you want to know, especially for this kind of coupling between speech and gesture, speech and movement of any kind, you want to know when the loudest point of the speech is, and you also want to know when the most kind of forceful, I know there's been a couple of terms for this, whatever kind of the peak of the movement. And in that sense, it could be that you do this kind of really big movement, but could be very small. So then size and distance, these things don't matter. What matters is really where is the force, and that's usually that peak of velocity. And so this kind of makes just a good starting point for calculating other things as well.
Is there easing in some of this also?
There can be, yeah.
You know, that is, there's ease in and ease out. And I'm wondering, when you're doing this, I'm watching you going, oh, wow, that's really interesting. It could be fast and then slow as you reach the peak, or slow and then fast as you reach the peak, that kind of thing. You know?
Yeah, exactly. So that's, again, it's something I'll go into a bit more in the next module in terms of capturing more diverse aspects. So for example, the peak velocity, how fast do you get to it? There's also a bit on the variation in the rhythm of the movement. So indeed, are you doing something that's kind of just this rhythmic thing, or is it really kind of slow and then fast, for example? So this is indeed, these are all kind of different aspects you can consider and try to get out in terms of features. So I think for this module is really kind of a basic, here's the thing you can do, and then the next one will go into more different kinematic features, and those can then also be applied to the face in that sense. Yeah.
I also have a broad question, if you can indulge me. So in Johnson's research group, we're also concerned about use case applications, and we always have two maybe extreme users in mind for open face: babies and really like my grandma. What would be your 2 cents on how much surprise are we up for having trained open face on this kind of middle range applications, and then if we move into like healthcare for like senior homes or like wrinkled faces and all that. Is that something that is a field of opportunity, or you've come across that in your work and in terms of its application?
Yeah, interesting. To be very honest, I have not seen or tried OpenFace with kind of the extremes of age, so I'm not sure how well it performs in terms of tracking. I would be curious to see. I would say in terms of any of these kinds of analyses, if you're looking at whether it's the coupling between facial signals and speech, for example, or these kind of exaggerative features that you would use, anything has to be kind of relative to some kind of baseline. So typically what I would have is different kinds of intentions that you're trying to compare to one another. You might also be interested in different kinds of annotations. Let's say if someone's uttering something about this or about that, are they in a kind of collaborative mode or a more argumentative mode? So these kinds of comparisons, I think as long as they're within group, it would be fine, assuming the tracking itself actually works. And that's, like I said, I'm not sure at the moment how well that would be. Could be that it's perfectly fine, could be that it performs less well, but I'm not personally aware of any research on that at the moment. Okay, I don't see any more questions in the chat, so I think I'll just go ahead and move on to the next module. So thanks everyone for your engagement, for your questions. Definitely good to be discussing these things. So I want to just spend a moment really to, oh, I should stop my share and switch real quick, to kind of contextualize what this next bit is. We've now had a bit of discussion, maybe spoiled it a tiny bit in terms of what I'm going to talk about and why it's interesting to me, but I'll just kind of move through this kind of quickly to give you an idea. So this next module is about kinematic features. In particular, I've done a lot of research in terms of how people move differently depending on the context and what they're in. So essentially what I want to do with this little bit is just to kind of give you an idea of why should we care about kinematic features? Why should we care about variation of movement? And the answer to that is essentially that people move differently and they gesture differently depending on the context in which you place them. For example, in these examples, they had in one study from Spencer Kelly and colleagues, they had people describing how to use camping, I believe camping or hiking equipment, either to a group of students that they believed were simply having to kind of listen to as kind of educational, they just need to know about it, or to a group of students who were going to go on a hiking, camping trip in the mountains and would be using this little educational video to kind of survive in the wilderness. And so this difference in motivation for basically how relevant the information was changed, especially the frequency and I believe also the size of and the types of gestures that they produced, showing that people essentially changed their communicative behavior depending on the relevance. Similarly, this was from Campisi and Ozurek. They had someone describing how to make coffee using a particular coffee maker. And they had this, they basically had to describe this process to either a child who obviously does not know how to make coffee, to an adult who is not familiar with making coffee, or to an adult who really is familiar and knows how to do this. And the kind of key summary finding here is that people produced really similar iconic gestures at similar points. So for example, putting the coffee into this little bowl, but depending on who they were gesturing for, they gestured it very differently. So for example, if they were doing it for the adult who already knew about it, they just say, yeah, you put the coffee in the bowl, and they do this kind of like scooping or dumping gesture. If it's for someone who knows a bit about it, for example, then they would actually have a more refined one. And if it's for the child who really has no idea, then they say, yeah, you put the coffee in the bowl. And they do this two-handed, iconically depicting a bowl, iconically depicting the scooping and the dumping. And so basically just to give the idea that people really change the way that they actually produce these signals depending on their addressee or in general their communicative context, which I think is a really cool finding. Yeah, so this is one way, these kinematic features I think are one way to kind of quantify these differences a bit more than just saying it's complexity or it's a bit bigger. Let's see really what is happening. And so this is just to give you a taste of a bit of what we're going to go into with this. This is from my PhD work where we tried to quantify kinematic features that are relevant for communication. And just to kind of contextualize this so you see how it works, what we have is some still frames from a very simple, iconic kind of pantomime gesture where she is going to depict how to place the apple into the bowl. I use this because it's very simple to see the velocity profile here on the bottom. And what you see essentially is these peaks corresponding to the first movement of reaching and grasping the apple and then moving the apple to the bowl. This gray block is in a pause where she doesn't really move her hand, and then she retracts it. And so this is kind of getting at your question, Jonathan, about the why do we care about velocity? Well, these are all kind of the cool things we can get from getting velocity. We can look at the number of sub-movements that are produced. So how kind of complex is this in terms of how many movements does it consist of? Are there holds being produced? In this case, she does this kind of grab, move, pause, and then retract. So really kind of framing this a bit more. We can also look at the peak velocity. So is this kind of just a smooth move, 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 or is this really like a bam, this is it?
Like here's the moment, right?
Yeah, exactly.
Yeah.
This is, look at this. And then beyond velocity, we can also look at more spatial aspects. So for example, we can look at the volume. If we can imagine a bounding box around the hands, as you move around, it expands in either 2 or 3 dimensions, depending on your tracking. And we can, yes, look at the McNeelian space. I'll go into this a bit more, but essentially, what kind of space around you are you utilizing with your hands? Okay, and then a bit about the relevance. So I already mentioned a bit about intention signaling. So there's been a lot of work showing that basically our intention, what we want to do with an action or a gesture, is kind of revealed in our kinematics. So this is from a paper from Cristina Becchio and colleagues, showing that, for example, if you have a bottle in front of you, the person reaches, they grasp the bottle, before anything else happens, you can already see the kinematics of this reach to grasp movement can quite accurately be kind of split apart and classify whether they're going to then grasp it to pour it, to pass it to someone else, to drink it, or to, I think, then place it elsewhere on the table. So before anything else happens, you just see reach to grasp. These intentions are already there. So this is kind of this ecological framing of our bodily movements, that everything we're doing is contextualized even before it happens. And this is something that I worked on throughout my PhD, also showing that our concrete intentions and our abstract intentions, in this case, the concrete would be kind of what we just showed. What are you doing? The abstract intention is more the social aspect. Am I doing this to demonstrate for you how to do it? Am I doing it to kind of instruct someone else who's done it wrong? Am I doing it just because I'm practicing it? These kinds of things are all also revealed in the way that we produce actions and gestures. And if you give an observer, you let them watch this, different features, different kinematic aspects of the gesture will also help the person to understand which one it is. So for example, the hold, the segmentation, if this is more, then they're better able to understand what this gesture is about. The size of the gesture will reveal to them more about the social intention that they have. We've also done a study, I've mentioned a bit about that in terms of people speaking in noise, where we had someone, they had to communicate action verbs to the other person, they had headphones on with a lot of noise. And here we also found that people changed the kinematics of their gestures, also of their face, also their speech. So this is also relevant for that. So this is kind of an example of this where, that's a bit odd, but essentially, yeah, the arrows are a bit confusing there, but what you're supposed to see essentially is that the person in a very noisy environment, she's trying to convey the Dutch action word stempelen, which is to stamp. And she does these kind of many kind of stamping movements. Rather than just doing one, she does them all, also timed with her speech, which is quite nice. And this is also a study from women colleagues showing that also these kinematic features correlate with human annotated information units. So this could also kind of get at the informativeness of gesture as well. So this is just kind of a quick, I'm not trying to give like a kind of scientific talk about all these different things, but just to kind of give you an idea of what the relevance is of this kind of quantification of behavior, let's say. And also to kind of give you an introduction to the type of features that we're going to quantify. These are most of them. We also have a couple of others. So just switching my screen, sharing again. So you should be able to see now my notebook, yeah. Right, so we're just going to jump right into this. This is going to get into essentially how to start quantifying kinematic features. I'm applying this to hand gestures specifically, but you could do this, for example, with eyebrow movements, probably with some kind of changes to the code, essentially. Just as a note about this, the same code as just kind of Python scripts is also available at my GitHub. You can find it here, Kinematic Feature Extract. I listed here because this is essentially my ongoing kind of project of modifying and changing it. So it's a bit of additional functionality in there and different kind of things set as different scripts. So there can be, if you're interested in using it, it's all there. If you're more comfortable with MATLAB, I originally developed it in MATLAB, so you also have MATLAB scripts there. Right, so I've given you the theoretical introduction. We don't have to go over this again. This first bit is a bit of script that allows us to extract the essentially the kinematic or the motion tracking data from our JSON files. So this is, yeah, I don't necessarily want to go into this in too much detail. It's really just going through because you have many JSON files, and this is a way to kind of get the bits that you want. So for example, the X, Y values of the hand, the nose, the neck, the hips, the eyes, and we're going to use all of these different features in order to calculate some relevant kinematic features. And then this will just return a data frame, as you can see here, with our XY values for these different points on the body. Very simple. Same with this one. It's basically what you saw as well for the face tracking. This is just a way to get the displacement values and the velocity values for a time series. So this one isn't relative to anything else. This is really just to get something that's happening. Very simple. Mean positioning, also just it's going to be used by some other functions. Really just to say if you have like a time series of, let's say, the right hand, where is it on average in this time period? Doesn't really do a whole lot by itself, but we'll use it later. And then just a little function to write data to file, all quite simple. What we're going to use for this is some data from a silent gesture of someone playing an accordion. See if I have something in here. No. Okay, then let me see if I can just show this real quick because I think this will be useful to see what we're actually getting at. Yeah, you can't see anything on the screen. I'm going to switch in just a moment. I just have to grab the video. But essentially the idea is that this is just a very simple short video as an example where we want to see someone producing this kind of iconic gesture. And we're going to quantify some aspects of it. So I'm just going to share screen for a moment. Yeah, very simple. Not a whole lot going on other than person in frame, they produce a gesture, and then we go on. The reason that this is kind of interesting, though, is that this is a good case example of something that we might extract many of these from an ongoing video. For example, the different gestures that someone produces throughout, and we want to kind of look at them one at a time and quantify the kind of movement characteristics of them. So we're going to use this as kind of a starting point. The first thing that we want to do for this type of data, and this is kind of, I leave this in there a bit as kind of an educational thing, I guess, as well. I flipped the data around because if you're familiar with how image processing works, the X value so X and Y start in the top left of the screen. The X value runs from left to right, as you would expect, but since it's at the top, the Y value goes down. So the values go up as you move down the image. To me, this is very unintuitive and makes me unable to work on it. So I just do this very simple calculation where we take the maximum values and essentially flip everything upside down so that the head has a higher Y value than, for example, the hips. This is also easier for interpreting some things. For example, like volume and velocity doesn't matter, but if we want to look at the height of a movement, then it's a lot easier to kind of get at this rather than negative values or lower numbers or something. So again, just a very simple thing to flip this over. And then to give you kind of an example of the type of data frame that you'd get after extracting from this JSON file, this is what we're going to be working with right here. So as you can see, I already mentioned that we have a column for each of our points. And then what I have set up is that it's essentially an X and a Y value in one column. So this is quite handy. It's not very intuitive for printing onto an Excel or CSV file, but for Python, this is no problem. And we can always just query the two values separately or put them into a function together, which makes it kind of nice. So let's get into the kinematic features, right? So the first one, it's fairly simple. It's long code, but it's a fairly simple idea, and it's vertical amplitude. So this is the idea that people might produce something just in general higher up in space in relation to their body. This is something we found also in terms of the social intentions that people have. And the way this works is not going into it in a pixel-wise difference per se, but we want to know relative to the person. So this splits it up into the maximum height being below kind of the midline of the body here, or it could be kind of between here and upper middle, and essentially taking these kind of slices going up. And what this does is we first have to calculate these different points, but we're able to get at all of them because we have things like the neck, the nose, the eyes, and we can use that to kind of calculate where these different midpoints should be. Whether it's on the nose or even a point that we have or not, we know approximately where they should be on the x-axis. And then we just go through and we essentially compare them to these different, these y values. And the idea is that this does this, these calculations happen, as you can see in this loop, on a frame-by-frame basis. So what this means, effectively, is that by calculating this on a frame-by-frame basis, if the person is, we'll say, kind of sitting like this and gesturing like this, but then they sit back up, and my hand position has now moved on the screen in your view, but relative to my body, it hasn't because I moved it with it. And by calculating this value on a frame-by-frame basis, we essentially capture this aspect of it without being messed up by the person moving around, whether they're kind of gesturing right here, and then maybe they go and they kind of sit down somewhere else, they keep gesturing. We want to know in relation to my kind of gesture space, what is the maximum height for this gesture? Very simple, but I think it's still kind of a powerful tool to use. Yeah, and then in this case, for example, we've calculated for the accordion, we get a max height value of 1. So we see between the midline and the middle upper body, so kind of in this area of the body, and that's what you should have seen in the accordion because he's kind of moving like this. The max value is probably somewhere right around here. But you can imagine if you do this kind of huge accordion movement, that's going to be a bit different, and then you'd also be able to capture this quite easily there. And it's something that's kind of categorically easy to understand, I think. Okay, now we can also make this a bit more complex and say, well, this height is one thing, that's very nice, that's fine, but what if I want to know more about where in this kind of larger, at least two-dimensional space is this happening? So for people who are familiar with gesture studies, you're probably well aware of David McNeil's delineation of gesture space. This is this kind of blocking of having this kind of center area, the center, the periphery, and then the extreme periphery, with the idea that things that are kind of salient might be all kind of really right in the middle, right in this kind of central area. But if you're exaggerating things, you might also put them further out into space. So depending on what you're doing and how you want to depict it, you might use different aspects of space. You might also change, for example, how much of that space you use. Do you really keep it all in the center, or do you really, like the accordion, do you move it out and use kind of various points of this? So this is a way to kind of capture dynamically how much of the area around you are you actually utilizing for a given gesture. The difficult thing about this delineation, as you can probably see, is it's not a very easy thing to just look at and code. It's something that people typically have kind of lined out on a screen, for example. But again, if the person moves, even if they shift posture, you have to be able to kind of move this around with them. If they lean forward or do something that kind of contorts their body, it becomes really difficult because you can't shift it as much on the screen. So this is, I think, one thing that's a bit difficult to actually utilize in practice in video coding. But it's a great way to show the power of doing this kind of algorithmically using motion tracking. So what we do, again, I'm not going to go through line by line on this one just because it's a lot, because you have to kind of make it a lot. But what we want to do is calculate on a frame-by-frame basis where is the hand at this moment. And we're going to use this kind of long code in general, and this is going to also utilize this define McNeilian grid code. And what this does is, because we know approximately from this little drawing where all of the different boundaries should be, it's literally going to draw a grid based on the motion tracking data onto the person's body. And then that frame is going to, that calculation is going to use that. So if the person kind of leans to the side and is gesturing, the grid will also shift with them. If they lean back, this grid will also kind of contort back with them. And this is a way to kind of utilize this aspect of their personal space that they're utilizing without having to also kind of redraw and recontort it yourself frame by frame. Yes?
Surely the change in the grid itself, meaning the specific position of the grid, is also a signature.
Could be, yeah,
Right.
yeah. Yeah, that was also be, I hadn't thought about it before. It seems really interesting though, indeed, the way that you utilize it.
I'm just watching you and going, gosh, people must have, I mean, it's in early physics, that's called like a Galileo transform, where you're changing, it makes calculations easier, right?
Right, yeah.
And, but what I'm thinking is each one of those, people could have characteristic things that could also have meaning. How far back do they go? How forward? Are they making that space bigger, or are they keeping that space relatively fixed?
Yeah, exactly. No, this would be a cool thing to look at, indeed. See how kind of contorted it is, and yeah, good point. Right, so what this function does, it doesn't do anything with calculation of the grid, unfortunately, but it will give you a few different aspects of the space use. For example, how many different spaces were utilized? Is this something that's going all over? What is the maximum if you're assuming kind of the main one, center, periphery, extra periphery, and the mode, which is essentially the one that is most used. So it could be that you're mainly kind of gesturing here and you do something out there. You use maybe 3, but you're mainly in this one. And then it might be good to know which one. And so you can get that and post that up. So for this one, for example, we see 4 different spaces were used. In this case, it was the center, 2 in the periphery, and 1 in the extra periphery. And space 4, the extra periphery, is also the most maximal one and the one where the hand is spent the most of the time. So basically moves in, kind of has this pause, and you have this kind of build up there. Another way to think about this, I mentioned before, is the volumetric size. Again, this is just kind of a simple calculation of taking bounding xy values for the hand at every given frame. If it comes to this x value and kind of this y value, you take that as the new max, and as the frame, as it kind of progresses, you just keep those. If it moves out a bit more, then these expand out as well. This gives you this kind of volumetric space. So you can see, for example, you can do this either for both hands, so you have the option to tell it, do I want to calculate for both, do I want to just know about one? And this gives you the volume there. Peak velocity, also quite simple. This is just telling you what the maximum value is. So again, this kind of tells you something about how kind of forceful it might be. We don't use like mean velocity because it could be if you have pauses throughout or different movements, this can be kind of distorted a bit. If you have like one peak and a long pause, this will also be, the mean becomes a bit uninterpretable in a way. So we kind of separate them out. Just say, what's the peak? Is there something very, very fast in there or not? And here we can see we get this in pixels per second, since this is what the calculation is. The number of sub-movements, I also kind of alluded to this in the velocity plot where you see this kind of this string of things happening. Essentially what this is going to do is then try to find the different peaks in the signal, and then it's going to see how many are there. Again, a very simple thing, but it is kind of informative about what's happening. Because this can be whether the complexity of the signal, for example, or kind of how repetitive it is in the case of this, this stamping motion. Do you do it just twice? Do you do it 10 times, etc.? So an interesting thing, I left this in here because I think it's a good kind of discussion point. You saw the accordion movement it's with both hands, but our calculation gives 2 different numbers, so one for the left, one for the right, and they aren't quite the same. So something I left in to kind of show a good point about how these calculations are being made. So this block, I'm just going to plot this out and then use the values we get from here, from this find peak algorithm, to get the numbers. And then we see this is the right and the left. And we can already see that, well, the top ones, those are all fine. We do have one extra one here. This might just be the smoothness of the movement. You can imagine if you kind of like pause a little bit on one hand, you'll still get a little bit more, but you also have a little bit more at the beginning here. So this is something just to keep in mind in terms of how smooth is the movement, how is it being clipped off. It could be that something looks to us, just on a first glance, something like this, that it looks like both hands have the same number of movements, but depending on how smooth it is, this might actually differ. And this is something that was also in kind of classic movement, kind of motor control studies have shown as well. Something as simple as reaching to grab, we would say, well, that's one movement, but it's at least two, because you have an initial, what they call ballistic movement out to the object, and then you have a correction where you go out and then correct down. And so this is something, depending on how good your signal is, you can also capture this. We also see this with the reaching to grab the apple, that we would also often see that with a good signal, you get at least two movements in this one thing, where you have a peak and then a smaller peak on this one kind of larger waveform.
James?
Yes?
So I think you could also say that these are not real peaks, right? So you could have a threshold on your fine peaks.
Absolutely, yeah.
Depends how much you're interested in.
Yeah, it's a good point.
The first one, it's the local maximum, but it's like
Yeah.
the minimum, right?
Yeah, so for these, I would also say, so this is a bit of an issue here in the sense that it kind of cuts off, or it starts a little bit too early, because there are these peaks here. So depending on how you set that up, because what this should do is not find anything that's happening before the first actual full movement. But in this case, because it's a bit of a jittery start, yeah, absolutely. Okay, hold time. Then I'll try to go through this a bit quickly for these last couple ones. You can go through it in more detail at home. Hold time is just this kind of longer block of code, essentially, where we try to find pauses in the movement. What's good to mention or good to know about this is we're utilizing not just the hands, but essentially the whole body, depending on how much information you give it. It's not that, for example, the person is sitting here moving their elbows or something, or kind of shifting around. It has to be that the whole kind of articulator is paused during that time. So this is basically just checking, again, are there movements happening? Is it really paused during any moment, essentially? And it will go through, it will find those moments, and then it will try to kind of bring them together. So finding these little blocks, and then seeing, for example, if this is the elbow is paused here, the hands are paused here, then we know this kind of intersection of the two signals, this is a hold, for example. And what we get out of this, as you can see, you'll have the number of holds being produced, the hold time, and the average time per hold. So for example, if someone does a couple of them, they pause again, you might have two holds, you'll have the average time that they actually did this pause, and you'll also have the overall kind of time spent paused throughout, so related to the duration. Rhythmicity, this is also something you can calculate in terms of the overall signal. So this is essentially just getting the temporal interval. In this case, I'm using sub-movements. So we see that we have, for example, these many different movements being produced. Is this really a very rhythmic back and forth in a very steady rhythm, or is it something that's kind of jittery, stops, moves, and then maybe a bit more movements? Basically, how well can you predict this on across the whole movement? And we get this value that is essentially the standard deviation of the temporal interval. So essentially, they have a standard deviation of 5 and 8 frames between the sub-movements. So this, again, maybe not super informative for just one case, but if you were to compare this across multiple gestures, then you would have a good idea of what's happening, or what's different, essentially. Yeah, I think since I'm out of time, I won't go over this. This is a bit of a comparison. This last bit, you can look at it at home and see if you have any questions. It's a comparison between the media pipe tracking and the open pose. So this gives you a little bit of code to convert the two into a similar data frame structure, so you can really easily run these functions on either one. As you can kind of see, we do some kind of comparison calculations. Some of the differences are also the system that's being used. We do some calculations showing the difference in the peaks, for example. And just to see that it's actually quite similar what it gets, but you do have to tweak some of the parameters. For example, like Wim mentioned, in terms of how smooth it's going to be, how much of a peak does it need to be, depending on what kind of tracking system that you use. And it's just something you should kind of look at with your data to see what works best. I leave this as an open question because we are interested in collaboration and kind of moving this forward. One of the difficulties is that some of these systems provide you with data in different systems. So in pixels, which can change depending on the video. Now you also sometimes have them in meters, but is this also comparable between people of different sizes, for example, of heights or whatever? So I think it's good to have some kind of standard set that we can use for this. It doesn't matter. It's just about the movement per se. But this is kind of an open thing. So sorry for running a little bit over time. Yeah, if we have time for questions, happy. Otherwise, send me an email or chat with me at some other point. So thanks, everyone.
Time at the end of the day.
We also have time at the end of the day. Yes, yes, plenty of time for questions.
Or maybe it would be nice to have the question.
Do we have a short time for questions now, or are we going straight into coffee
Nice,
break?
right? Has anybody a question? Somebody?
Gregor Kachel.
Ah,
You
yes.
want to unmute yourself, please?
Thank you so much. I would like to know if you can use the gesture analyses that you just showed and throw them bluntly on somebody speaking. Like the examples you were showing were just one person doing a specific gesture front up. But can I, for example, use 10 TED Talks and go like, give me everything that the speaker does, and maybe then get an idea of, well, people that are from this field gesture differently or more engaging than people from, like, this is just a pet question, but you get the idea. Can I just throw it on one speaker talking for 10 minutes and be like, have information?
Yeah, I definitely get it. Thanks. It's an interesting question. I think it's a good question to ask. My answer, I think, would be I wouldn't advise doing it that way, simply because most of these features are kind of developed in the thinking of being about a gesture. So I don't know how informative it will be if you just throw it on a single person who might produce many gestures. Of course, then you could more easily just calculate gesture rate, for example. But what you can do, you have now some systems for doing automatic detection of movements or gestures. So we have this Sputnik system that's also been recently released that does automatic detection based on OpenPose of at least movements. And this also provides the annotations of them. So it just takes the kind of tracking of the hands and it says, here's a movement, here's a movement, here's a movement. And you could then use that either just if you're interested in kind of a blunt force kind of analysis of what people are doing, feed that to this loop and then go through, quantify all of these values for each of the movements that they produce, summarize that, and then look at that across participants, or do something more like mixed models with giving it all of the data points for this participant, all the data points for that participant, and then seeing if you can kind of see any differences on that level. But I would try to relate it to individual blocks of movement, whether this is an action, a gesture, something like that, and try to capture it that way. Yeah. Yes.
This is amazing stuff. I'm struck by the McNeil grid, and I'm thinking about two things. One, in our work, we saw that networks were very often described like this, right? And that corresponded to the level of change from the center of something. Not that it wasn't important, these were incredibly significant, but they were far from the original center of something. And maybe the person was in the center, but also we have a gesture, we go like this, which is a very Italian gesture. If you look at Bruno Minari's book about gestures and language, I would love to do an analysis, like looking at, okay, so where is this happening in the space? How does it indicate things? But this is the core of something,
Yeah.
right? This is what we used to say, what is the core? And it goes right, it really is right in the center of that space. So I'm finding this super interesting, like multitudes that are important, right? And singular deep things like this within those spaces. It's, there's a lot we could do.
Yes, absolutely. And I think indeed it's not a case of saying that this is important, this is not. It can be completely the reverse. It could be more about how many you utilize. It could be really kind of contextual. But that's the kind of cool thing about this, is that you do have an idea of what are they doing with space, and then it's kind of up to your research question or your data essentially. What part of that is interesting? Is it really something that's happening mainly in this one space? Does this mean something? Is this related to the semantic content?
Right.
Etc. Yeah. Yeah.
And you know, in terms of kids as opposed to adults, the child's, shall we say, McNeil space is going to be smaller, right? So that gives us a interesting reference point, or a perhaps useful reference point to say, children's gestures might be this big, but their box is this big.
Yeah, yeah, exactly. So that makes it a nicer comparison than just saying kind of a pixel volume space, because indeed they're smaller. They're still using the same space around them, indeed.
Right.
Yeah, yeah.
Right.
Yeah, good point. Any more questions for now, or shall we go to the break?
If you need Italians, we can volunteer.
Yes, good gesture. It's perfect.
Did you say the Minari book? It's just beautiful about.
Yeah, I mean, and we say que cosa
Yeah,
usually
that's right.
together with
That's
this,
right.
yeah.
Do some kinematic analysis of that later.
Yeah, I'd say let's grab a quick coffee and then be back here in 7 minutes.
Thanks again.
Yeah. Thank you, James. We'll see you after the break with him.
Sorry, technician.
Yeah, technician.
Yes.
How was it? Did you like it?
Yeah, it works really well. Yeah. It's super easy once it's actually nice and like you don't have to do it here, because I tried to fix it and it just didn't
I'm Jonathan.
like it kept falling out and like
Nice to meet you.
I'm glad I could help.
Yeah, it's
All that work with the technician and the SAS.
yeah.
Thank you. This looks like an amazing
For the recording.
Yeah, exactly.
Okay, I think we're about to start. I'll put this on one.
Annotating also my I have been. I have been annotating gesture manual as well.
Okay. So, Shokin, you can hear me, right? Yeah? Okay. No? You don't hear me? Okay, wait. Baba?
Yeah,
You
no,
know?
yeah. No.
Yeah? Okay, we're fine. Okay, let's start. Because I don't have a lot of time. So, communicative movements, right? We have been looking at movement features, so it's also kind of abstracting away from the continuous events and trying to get summary values of certain aspects or qualities, right? We might be interested in multimodal timing and rhythms, right? It's a field that it's really, or a subfield within this niche that I am also very much enthused about. But there's also something like movement as recurrent patterns. Movements are not produced in a vacuum. They are often produced within the set of movements that you're producing. And often, if we think about how meaning is generated, and something that we have to remind ourselves, I think, more often of, is that sometimes the same movement can have a different meaning. So the meaning is not in the signal, right? The meaning is always, in a semiotic perspective, it's always a function of the thing that you're referring to, the thing that completes the reference, and the thing that tries to do the referring. And in that sense, you never know if you're pointing to a rabbit, whether you're pointing to the ears, or you're pointing to the fur. Often, it's not in the kinematics. You can do media pipe analysis on the pointing movement, but you will never know what the true meaning is or what the true reference is because that's in the context. So that's also something you have to remind ourselves of when we're thinking about kinematics. So only if I talk about maybe a different kind of fabrics, then pointing at a rabbit then might complete the reference that I'm pointing to the fur and not the ears, right? So context is important. There's a whole ecology of meaning making that is not in the signal itself, right? A smile can be evil or it can be a fun smile depending on the context. So we need to take the context into account. So, like I said, kinematic form of a gesture does not equal the meaning of a gesture. It's simply not possible. You need someone or something to complete the reference and some context that need to be taken into account. Well, one context that we can get out of the signal itself. So we don't need to look at very other complex contextual factors that might change what a gesture means. The context of a gesture is also the context, how a gesture functions within the set of gestures that you're producing, for example. So a gesture may attain meaning or may attain some special status in your discourse because it is different from all the other gestures you produced. And in that sense, we may want to know or want to look at the recurrent patterns that occur in gestures. So one way we can do this, let's say that this person is producing several gestures that we might see as units. Let's categorize those units, and each unit we can characterize kinematically with a set of time series, for example, multiple key joints that are moving through time, right? And we can say, well, maybe we can do something like, let's compare every event in terms of the kinematic structure, and let's compare it to all the other events that happen, right? So all the combinations of the set of gestures that you're producing, let's compute some kind of dissimilarity measures. You can choose all kinds of dissimilarity measures. For example, you could say, I want to see what the difference is in the rhythm that a gesture has. So you could do like a Cross-Kublek-Leibler divergence, trying to see whether the rhythms that are in one gesture are also in the other one. Or you could do something about whether we're interested in form. Is it the case that if I make a gesture like this, and at the other time I make a gesture like this, how much similarity do these patterns have? They do have some similarity, right? And there are good data science methods for time series analysis to actually compute something like a kinematic distance. So we are using dynamic time warping. And remember that if you are producing all possible dissimilarities between a set of gestures, then you're actually mapping out the kinematic space, what the degrees of freedom are or that have been used. And you can actually have something like a kinematic space like this, where every node is a particular gesture, and nodes that are closer together are gestures that were more similar. And those that are further from each other, they are more dissimilar. And in that way, you can have a quick visualization of the type of structure or the kinematic space that it's being occupied by a particular person. So the dynamic time warping main procedure that we're using, but like I said, there are many measures that you could use, like matrix profile distance or whatever, but we're using dynamic time warping. It's a classic kind of approach where you say you have two time series. They can be multidimensional, right? Here we only have one dimensional, and you have a time series 1, and you have a time series 2. And let's compare if we try to align them first in time. So let's morph them, let's warp time such that they are maximally aligned. And how much distance is there still when we have this warping? So even if I have a fast movement like around like this or a slower movement, these are the same patterns, and then the dynamic time warping will warp it such that you have a really low distance between those. What is the minimal distance between these time series if we allow time to be warped, and some other rules? So the other rule is that you have a certain ordering that you want to abide to, right? You cannot just flip the time series. Well, in these two cases, the right example, this is a higher dynamic time warping distance because simply these time series are less similar, right? And we can generalize this to often any kind of movement is defined by maybe 28 dimensions or whatever, right? You have X, Y, and Z values for one key point, and what if you have more key points? You can generalize this to a multidimensional kind of space where you say we're doing this aligning. Let's see how dissimilar these time series are, how dissimilar these multidimensional time series are. So often I will take the index finger, the thumb, the nose, maybe some other key joints. So kinematic spaces, you could see it as a weighted network because what we're doing is for each gesture Y, we're going to compare it to all other gestures within the set. Let's say the other gesture is J. And we can compare every gesture, and what you get is essentially a matrix where you have the row. I'm going to compare gesture 1 with gesture 1. You'll get a 0 distance, right? It's the same gesture. And then with gesture 2, you get a certain distance and so forth, right? And you fill up a matrix like that. And this is what we're going to do for the module. You could call this a weighted network. It's not really a network yet. So we could also say, well, you can make networks out of it, and you can apply network measures to it by, for example, pruning the distance matrix into a more an adjacency matrix. So you replace the continuous to you say, well, I'm gonna only keep those distances that were at least somewhat related, and then you have a proper network. And you can apply all kinds of measures that Ludovica and Andrea will be talking about as well, I think. So I'm not going too much in the network or the definition that I'm using here. I like the word gesture networks, so I'll stick to that. But essentially what we're doing computations on are these distance matrices, and sometimes it's interesting to do a proper network analysis on it too. So for example, you can imagine what if we have a group of speakers that are from different countries? If we plot the kinematic space, can we categorize that kinematic space such that we can differentiate between these two languages? This is mock data. We have not found such a thing, but that's an interesting question, right? And you can also see that it doesn't matter. We can generalize this network or this kind of approach where we compute all distances between a set of gestures, that the set of gestures could be multiple persons, right? It could be anybody. It could be a lot of persons producing gestures, and we can actually see that some people occupy maybe different regions in the kinematic space, or people are aligning. That means that the kinematic spaces would start to overlap, and that's something that we'll talk about in the multivariate one as well. So one of the studies that we did, for example, with this kind of approach is that people need to do silent gestures, and they need to, for example, they cannot talk, but they do have to express, for example, the word chef. So maybe you would do a cooking gesture, or cooking like a gesture, something like that. But then they also had to do frying pan. Well, I cannot use this again because that's ambiguous now. I already used it for chef, right? So maybe somebody would say, for frying pan, I would this, and I would make a gesture like this. So the problem of this particular conceptual space is that things overlap, right? There are multiple locations, words like restaurant and church, but there are also multiple food-related items. So you really need to be careful what kind of conceptual system you're gonna use. You have to be careful that things are not confused. So what we've done is on this particular data set from Jessamine Motomeda, a really great open data set. This is really the power of open science. We've done a reanalysis of of the experiment that they produced. So these people are, this is one person producing all these concepts, right? And we can do a gesture network of this, right? But what the cool thing was in this particular experiment by Jessamine Motomeda and colleagues is the task was for one person to invent a conceptual system, then communicate that to another person, and then that person will communicate it to the other person, to another person. So these are chains. And what happens in language? Things become systematic. People will use, for example, for location, they would say this, but for a person concept, they would use this. And what they found is they did this manual coding by looking at, well, we often see that people use this particular gesture to identify the person, because I only have to invent a limited amount of gesture to say, for example, I have a food and I have a person, which makes me a chef. But I have food and I have a location, which makes it a restaurant. So the complexity is reduced. It's actually, if you would produce an entropy on it, and that's what they did, entropy on the codings, they saw that the entropy went down. The complexity of the conceptual system was actually reducing because they were more optimally communicating this stuff. So this is a classic language evolution experiment where you have these different generations from 1 to 5. You have different chains. You can imagine that you get cultures, right? You have one chain of people and another chain of people, and they're gonna design their own kind of language, right? So you get these dialects, for example, or that's what we found. I'll show you this. But we're just going through this whole procedure, right? We're motion tracking, dynamic time warping for all the gestures within that set, and we're going to do some analysis on the distance matrices. So one thing we can do is we can also derive a measure, or we can also use an entropy kind of measure that they've used on the manual coding, but we can use it on the kinematic space. How complex is the kinematic space? So we use also kind of a Shannon entropy application for this, and what we found is that generally over time, each chain, over the generations, the complexity of the kinematic space reduced. So it's not only that it's some kind of symbolic thing, it's also within the movement, the kinematic space was reduced in its complexity over time. And this is, for example, shown in the kind of the variation in distances between all these gestures. We showed that the kinematic space also reduced in complexity. So the kind of movements that you're making when they are, when these movements are acquiring a certain linguistic systematicity, we can pick that up in the kinematics by looking at the complexity of the kinematic space. And indeed, we found that the original entropy calculation on the manual codings were very strongly related with our reduction of complexity in the kinematic space. And finally, we found that people, these different chains that were not communicating with each other, as the generations were older and older, you see that here in the generation 1, everything is a little bit merged, every color is a different chain, but at a certain moment, they start to sift. You get kinematic dialects. You get people using similar regions of the kinematic space to, and they were almost like, they were departing from each other because the language became more idiosyncratic, or the kinematic language became more idiosyncratic. So I'm going to stop here. We also found, for example, if you look at, for example, you have to communicate a concept to a robot, like whatever, a restaurant, and we could see, for example, we can ask, for example, if a particular concept is dissimilar semantically from another concept. For example, restaurant is quite close to food, but it's far from football, for example. We could see that we're using some kind of word-to-vec, which I think we'll follow up on in the semantic analysis as well, but we used word-to-vec to have these word concepts and produce a distance measure. And then we looked at the distance measure for the kinematics too, for a bunch of gestures that we produce. For example, in the kinematic space, you will see that bird and airplane are often were very close in the kinematic space. And indeed, we found a not so strong, but still a reliable correlation that also in the semantic space, this is also similar. So bird and airplane were also relatively closer in space. And this was correlated with the kinematic distances too. And it was across the whole space, even things that are very far apart were also correlated with other things that are very far apart in the kinematic distances. So one thing that what I take out of this kind of approach is that the distinction between continuous aspects of language, such as gesture or sign, and the cataclysmic kind of distinction between, on the one hand, language, which is discrete, it doesn't exist. Actually, you can analyze the continuous aspects of language and even still retrieve some of the things about language that you're interested in. So there is no break. And we don't have to have a bunch of people looking at gestures to encode what it means. You can also retrieve some of that contextuality by looking at the kinematic space itself. So I'm gonna go into the code. So let me, I can still, 1 second. I can just share my screen. So we have a gesture network module 1, and I'm just going to show you the foldering structure real quick. We have the scripts where our markdown lives. We have videos, and here is the set of videos. And it's a set of videos where an actor was producing different kind of gestures for different concepts. And the actor was actually copying some of the general ways that people tend to represent these kind of movements. So this is banana. I couldn't see it immediately. But okay, so we have a set of gestures by this actor. And we're going to produce a gesture network out of this. But also we had there were people rating how well the gesture communicated this particular concept. So we'll use those ratings as well. And I can show you here where we have the time series for all these, right? Because we've produced motion tracking with MediaPipe. We have the particular ratings about each video. This is an experiment, by the way, also open science, produced by Ortega and Owoyele. And we're using that data here. And we're going to produce a distance matrix, and we're going to save it here. So I'm going to go to my R Markdown. Maybe I can first go to here, and then go to the code a little bit later. So here is our Markdown HTML. We are loading in. We're loading in the motion tracking here as an example. And for example, here we have a swimming gesture. And I'm plotting here the time series of the left and the right hand for the horizontal dimension. One thing that you should know by now is that this is something we should smooth, right? I'm not doing it right now because I want to show you how robust the analysis is. But you see that at least you have these rhythmic movements that correspond with this particular gesture here. And let's go to the main routine. We want to analyze each time series that corresponds to all the gestures that are being produced. Here you notice also by now where all the folders need to be identified as such. Oh, let me set working directory as source file location. So everything we have iconicity ratings, right? Like a bunch of values for how well a particular concept was being rated as being informative or not about it. We're having a distance matrix where we save everything. Well, you can look at this. This should be familiar. Okay, so first thing, how are we going to characterize these movements? They were silent gestures, so they're primarily interested in hand movement, but there's also often some head movement in these kind of silent gestures. It's a whole body participation. So the first thing that we're going to do is list all the time series that are in my time series folder. I have a bunch of time series, right? So this is my time series object. Then it has all these concepts. in CSV files with all the information about the body movements. I'm going to extract a couple of key points, as little as possible, to show you that if you already have not so much information, you can still do some cool stuff with it. So first thing is, I have the index finger, X, Y, and Z. I have the right index finger, X, Y, and Z. Actually, this should be left, by the way. But and I have the elbow. I'm going to take the elbow key point. I'm going to take for both hands, right? And I'm also going to take nose movement. And I'm interested in the shapes. So I'm just going to leave everything there. I'm not going to normalize this time series because it's just one actor. I want to make sure that every gesture also is really compared in size as well. So these are my time series, a bunch of displacement vectors that I'm going to produce this dynamic time warping distance for. And DTW compare, or DTW compare, and not in Dutch, is my main function for producing this. And we're doing a particular version of this. Namely, I want to have for every key point, I want to have one computation of a dynamic time warping distance. So I'm going to compare, for example, the right index X, Y, and Z values with another gesture's index X, Y, and Z values. And I'm going to compute for every key point. So here I have 5 key points. I'm going to produce a dynamic time warping distance, and this is the main function for that. I'm going to produce a normalized distance because the normalized distance just normalizes for the different lengths of the time series. We don't care that one time series is longer than the other or not. We really want to normalize for time. And I'm going to produce 5 of them, and then I'm going to take the mean. So remember that a dynamic time warping, we're producing a multidimensional, and it's called a dependent dynamic time warping because we're doing a calculation in X, Y, and Z space with another X, Y, and Z space. But we're also doing an independent dynamic time warping because we're summing this for every key point. And ideally, you want to do an independent dynamic time warping if you have systems that are not as related, but you still want to take into account a particular, for example, different parts of the system. And you're doing a dependent one when they're actually part of the same system. The X, Y, Z are actually, for your index, are actually characterizing one system, right? Your index. Okay, so this is the function. We're going to use this in our loop. In our loop, we're going to set up some variables. We want to have a distance matrix. We know that we have 110 gestures in the folder, and our matrix is going to have a size of 110 rows and 110 columns. And we're going to fill every cell of that matrix with a distance computation. And so I'm going to set some things up. What are the number of gestures in our time series folder? So just the number of files is the same, right? We're going to make a matrix here with the number of rows is the same as the number of gestures for both columns and rows. It's a symmetric matrix. We're going to set the diagonal as 0 because we know that if we compare gesture 2 with the next gesture 2, if you compare something that's identical, you get 0 dynamic time warping. So we're not doing that calculation at all. We don't need it. And then we're going to initialize a catch names variable that we're going to fill in the names that we're taking for the gestures. Okay, and we're going to set an iterator at 0. Okay, so what we're doing is we have actually a loop within a loop, if you will. We're first going to loop through all the gestures, and then we're going to loop. We have a loop within that. This is the second loop. We're also getting all the gestures in the set, and we're just going to compare time series 1. We're going to load that time series in. We are taking the index of the time series to check which one are we at. We're going to catch the names. It's that what is the current gesture's name? For example, banana, as you saw, right? We're going to catch this, and then we say, well, we're going to compare this to the next time series, and the next time series is just the next one in that set. So for gesture 1, we're going to loop through gesture 1, which has a 0, isn't computed, to gesture 1 and 2, 1 and 3, 1 and 4, 1 and 6, and this repeats every time, right? When it's done, 1 in 110. This one goes to the second iterator, and then you're going to compare 2 with 1, 2 with 3, or 2 with 2, 2 with 3. You get it, right? So this is what we're doing with this loop. So here we are selecting a second time series. We take the index, check which index this particular time series was. We load it in, and so we read it, and then we have a time series 1 loaded here in, and a time series 2. We're going to compute the dynamic time warping distance. We call this dynamic time warping output, and by the way, I have an if statement here to say, well, if this distance matrix already has a value at that location, namely location TS2 index and TS1 index, the indices of the particular point. So position Y, J in a particular matrix is a particular cell, right? And if that's already filled with a value, we're not gonna add anything anymore. That's why we don't do any superfluous calculations. So we fill this dynamic time warping between TS1 and TS2, let's say gesture 1 and gesture 5 in a particular iteration. And we fill the distance matrix with that information. And we fill it up, and when it's done, we're going to give the column names of the distance matrix a particular value. I'm going to show you how the distance matrix, what it looks like. So here you have a long row, so you have 110 columns and 110 rows. I'm only showing the 6 first rows. You'll see that the first diagonals are 0 because you're comparing, for example, Apple silent gesture with this is also Apple silent gesture. It's symmetric, right? Diagonals are 0. And here we see, for example, that if we compare 1, the accordion gesture, with the Apple gesture, it has a dynamic time warping distance, combined rate of 0.10. The lower, the closer they are in kinematic. In kinematics, higher the number, the more distant they are. So this produces that. It takes a little bit of time, so I'm not running it here. And once we have produced the distance matrix, we only need to visualize it. We can have we have here, and I'm going to show it here because this is more fun. So the first thing that we can do is we have this distance matrix. Actually, every gesture has a particular location in the kinematic space. Namely, each location of a particular gesture in the kinematic space is defined by all the relationship with all other gestures. So actually, if you want to plot the real kinematic space, you would need 109 dimensions. But we need to reduce the dimensionality of this by saying, well, can you apply an algorithm where we reduce the complexity as such that we can plot the distances in 2D space or in Cartesian plane? And that's what I'm going to do here. We're going to load in our distance matrix. We're going to have a plot function using ggplot, and this is the function. Take some topology that we're producing via dimensionality reduction. So you get x and y values for each gesture, a title, give some clustering. For example, if we want to show colors by person, or just give them some colors, and we're just give them some colors by the name that they have, and the size of the point is just some how large you want to have your points, and this is what the plotting function is. And for the dimensionality reduction of the distance matrix to have 110 dimensions, we go to a 2-dimensional space. We use something, a dimensionality reduction technique called classic multidimensional scaling. And what we do is we have the distance matrix. In this particular distance matrix, we're a little bit long tail distributed, so a little bit of an outlier. So I'm going to do a logarithmic transformation to it. I'm going to say it's a matrix, not a data frame. I'm going to apply the multidimensional scaling, and I'm going to save this in my topology. And here I have loaded in a distance matrix, right? I can apply this multidimensional scaling. Is really fast, so I can show you what happens. Now I have, this is the distance matrix reduced in 2 dimensions. We have gesture 1, and we know the names. We saved that somewhere in our catch names. And this has a particular location in the kinematic space, in the 2D kinematic space, right? In the reduced one. And then we have this plot function that we're applying this plotting function. And let's plot the space. And what we get is essentially this space. And now what we can do is, well, we can actually hover over it, and we have, for each name, we can look at what it is. For example, we have these 2 gestures. These are quite similar. They should also be similar in the kinematic space. So I think this was bird and butterfly, and indeed they're close together. This makes sense because these two are very similar, right? The only difference is some wrist motion here. So this is one way of looking and hovering over the points, but you can also do an animated version of this. Namely, we can say, let's make an HTML page, and let's plot, based on the topology of the classic multidimensional scaling, X and Y positions, let's just plot all the videos that we have in one HTML file, and then we can look at it more dynamically, right? So with this code, I'm not going to get into it, but this code produces a HTML text and just loads in all the videos, says, well, where's its location, and plot it on your HTML file. I'm only going to do 33% of the videos, otherwise it gets really cluttered. And what you have is it's now loading all the gestures here. You can see if it makes sense. Does your particular calculation make sense in your space? Maybe you missed some relevant key points. Maybe your distance calculation is just not relevant for the thing that you're interested in. Maybe you're interested in rhythm and not in whether the shape is the same. So it's always good to point back to the data when you're producing anything, right? That's also something that a lesson that is general in the whole Envision Bootcamp. Don't just look at the numbers, also look at it dynamically, multimodally, right? If you do multimodal data analysis, you should also look multimodally at your data. I think that's a good takeaway as well. So this is now loaded in, right? It loads in all the videos. We see that these gestures are very similar in their kinematic space, according to our analysis. These ones are similar because you have these similar kind of movements. There is a little bit of more homogeneous cluttering here, so you could do cluster analysis to see, well, what kind of categories do we have in our, if we approach it bottom up, what kind of categories are likely there. And here you see a gesture like this, and it's similar like this. Well, you get it, right? This makes sense. And now you can think, well, if this makes sense, if this structure is to some extent real, we can do all kinds of calculations on the structure that's there, right? We can ask, well, how is this particular distance matrix, or if we prune this system and make it more like a network topology, we can ask all kinds of questions. How central is this particular gesture within the space, for example? Or we can ask, how well does a clustering algorithm identify whether this belongs to a person one or person two, right? We're going to generalize later on in the multivariate module to multiple persons. It doesn't need to be one person, right? So, and there are a bunch of things that we have done on this. And we have an example here where we say, well, we know that remember that we have for each gesture, we had how meaningful is this gesture, or how well does it communicate its meaning? We can ask, for example, well, if a gesture is meaningful within the kinematic space, how should it be situated? I would say that a gesture is very meaningful if it's not ambiguous with other gestures. If we operationalize that in this particular paradigm, we would say a gesture is maximally meaningful if it's maximally dissociated from other gestures, because if it's close to the rest, then it's difficult to maybe disambiguate. And then I would predict that maybe the iconicity ratings or the meaningful ratings would be lower. So one thing that we do here as an example application, totally not hypothesis driven at all, we can ask, well, what is the average distance of a gesture relative to its neighbors? And if the distance is higher, is it also more meaningful? And here we computed just a scatter plot, and it seems that there is a weak relationship that such that gestures that are maximally dissociated from its neighbors also have a more higher meaning rating. So there are a lot of considerations. I also go into that a little bit more in the HTML file or the notebook itself. For example, you really need to think about, how do I want to define something to be different or the same? And it depends on your context, right? Or maybe if you're interested in this gesture to be actually the same as this gesture, then what you would do is normalize the data set such that they occupy the same space. Or what if you have a gesture that is composed of multiple orders? So I'm doing this and then this. But maybe another gesture does this first and then does this. Well, if you're computing this with dynamic time warping, these things would be totally different. Well, if you ask a person, they would say, well, this is quite a similar gesture. The components are just ordered differently in time. So then you need a different kind of distance measure. Maybe you want to have a recurrence rate, or maybe you want to have, which is a matrix distance profile, where you say, I am going to window over my time series. I'm going to see if I order them differently, what is the minimum amount of distance that I can get. And then you can actually have different components. You can have a whole time series and just check if we reorder the components maximum to a point where there is minimum distance, then what you would find is that dynamic time warping would find this gesture different than this gesture, but the matrix profile distance would say these are exactly the same. So these are all kinds of the considerations. I think we should go for questions now. Yeah, so time for questions, I think.
Thank you, that was fabulous, again. I'm wondering about a statement you made towards the end, where you said that meaningfulness, it's more distinct if it's meaningful, but I'm thinking about poetry in which, for example, Richard II, Shakespeare, one of the most memorable moments is, I know no I, for I must nothing be. There's so much ambiguity, or shall we say he's using single words to indicate multiple networks of meaning that pile on each other. And we would say that's incredibly meaningful.
Yeah.
And so it seems to me clarity is one thing.
Yeah.
In the meaning box, clarity would be one thing, but also you can have high meaning from single multi-referent units, shall we say.
Yeah, definitely. Yeah, it's a classic, it's also a classic debate in cognitive science, is meaning the way in which you relate to other things or dissociate to other things. And there's probably some balance there. And also, of course, in terms of creativity, for example, things attain creativity if they're maybe they still have an association, but they're also maximally, at least as the association allows. It's like a string that at certain moment become absurd, but you just want to have maximally dissimilar as the association allows. So that's something you can do all kinds of analysis on this distance matrix and try to find out what the structure is in terms of how it disperses. You can also say, well, I want to connect my points, and that's what I'll do later, through time. So how fast are you jumping through this kinematic space? Is it maybe converging at some point? Or you can have different people and see indeed how they are aligned or over time. Do these two kinematic spaces start to merge? Yeah.
I thought also I really appreciate the video where you're showing the source materials and saying look at them.
Yeah.
And it never occurred to me
because you can be fooled.
Yeah. The accordion was close to the bird and the butterfly, and I believe it was a motorcycle because it was going like this. It reminds me of an exercise that we've given our students that is, don't worry about concepts. And I didn't have language for it, but now I do, is consider exploring the kinematic space. And one spectacular group, this was in Milan, they went from a wheelchair, just changing that space to where they were flying. And they came up with this tremendous concept for children in wheelchairs being able to fly. And it was just through exploring that space rather than a verbal concept space.
Yeah, that's what I liked, for example, by the kinematic dialects findings. Even gestures that were unrelated, like restaurant and I don't know, like a clerk or something. Even though they're not related, they were becoming closer in the space when these languages, silent gesture languages, became older. They still were more likely to occupy a similar kinematic space. And I wondered, why is this? Well, you're just reducing the degrees of freedom to make a system more meaningful, because you're making something systematic. It just doesn't make sense to have all degrees of freedom constantly used and variability being everywhere. It's always a balance between variability, keeping some variability, but also locking the degrees of freedom that you actually don't need to vary at all. And And that's, I think that's really nice to.
What's incredible, I'm thinking about the teams and how they, when they get to different places, we could say now they're in a more restricted kinematic space.
Yeah.
And it may be this might be the kinematic space, or it may be this, but they converge into different moments of less complexity.
Yeah. And remember, the kinematic space is the kinematic. So actually one thing that we're continue doing, James and I, is we have a gesture that has a really high dimensionality. How can we abstract away from it? And that's this one, you don't care about the content of the gestures necessarily anymore, but you care only about the interrelationships. And gestures that are completely different between two groups can have similar network structures. And that's, I think, the importance that you need to abstract away from something to see commonalities if they're on a more abstract plane, right? So I think that's important. It's one way of, that's also kinematic. If you take the kinematic features, you can compare gestures, even though they have different forms, they might have similar kind of rhythmicity, right? So it's always, we have something really complex like speech or gesture, and then we abstract away from it. And this is one way to do it.
One final note on this, and I apologize to everybody. Yeah.
Maybe some online.
It would be, one of the ways we get teams to get on the same page is to imitate each other's gestures, and thereby reducing the complexity in their interactions.
Yeah.
And we're very strict about it, but boy, then they're working great as a team.
Yeah, definitely. So. Yeah, I wonder how this will show in Team Dynamics, but it's a module 2, so maybe I hope you like it.
So we have 2 questions here now. If anyone has questions online, we'll take them after Andrea and Natasha. Yeah, so Andrea first.
So probably my comment was exactly about what you say last, but I find it, I mean, every time I see a network, I get excited. So I find all of this very intriguing, you know.
Yeah.
But still, what we noticed in social network analysis, in a very recent study, we take it from quantum physics and we call it entanglement, right? Yeah. But sometimes it's not just the synchronicity of the gestures within a theme, but sometimes you are just subconsciously synchronized with somebody else who is in another physical space. Maybe it's in another room or it's in another theme. So I think this idea of comparing the synchronicity between different groups, really, but not just groups that are communicating or interacting among each other, also groups that do different stuff. Because we find this when we do email social network analysis, we see that there is this kind of subconscious synchronicity, this kind of entanglement effect, and that people who synchronize subconsciously, really they do have an increase in performance. And it's really, so I'd be curious to see what comes out from that.
Yes, we think I like your way of thinking about synchrony. So synchrony, we think that is something that is always in real time, but we can be synchronized because we are synchronized to something on a larger time scale, maybe language patterns. And we might have similar ways of behaving because we're synchronizing on larger time scales that makes us behave, our behavior being constrained in a certain way, which is actually also just synchrony, right? It's just on a larger time scale. Yeah, I like that. Yeah.
I don't want you to talk too much because I don't want you to start to talk about your talk.
No, I won't.
Natasha, please.
Thank you. That was really fascinating, and I got everything that you were talking about to run on my laptop.
Oh yes. Oh, that's nice.
I'm very excited about that too.
Yeah. You can just drop in your own videos. Yeah.
The question that I have is also a thought experiment, but it's a very practical one for me. So I'm doing an experiment, and I'll be gathering data on Monday at a school. And it's a gesture experiment, and the question that is always in the back of my mind is, okay, is this a good gesture? So the question, so I have a comparison, and this is something that, that kids tend to mix up after I've been very, very deliberate about, teaching them, but it's a naturalistic experiment on purpose. So you have, kids distracting each other and thinking about something else, and that's all part of what we do. So the question is, I have a jump gesture and I have a frog gesture. And obviously frogs jump right? So I'm wondering, is there any kind of, so the practical question is this a gesture question? Like I need to get better gestures? Or is it a teaching question? And so I have to, put the microphone down.
Yeah.
So here, this is jump.
Yeah.
And this is frog.
Yeah.
And when I was testing the gestures, I purposely made frog a lot bigger because when I was teaching, I realized, okay, if you're not quite paying, if you're not quite paying attention, a frog could also do this. Like I noticed kids like correcting each other. So I'm wondering, I have more gestures, but that's like a particular question. Do I need to be more deliberate with the teaching?
Yeah.
And this is actually good?
Yeah.
Would there be some kind of an analysis that you could do of like kids doing the gestures, or I don't know. That's why it was a thought experiment for you, actually, not for me.
Yeah, if I think about it, there are all kinds of things that you could do, right? You can ask children to conceptualize in their hands particular concepts and then see whether their kinematic space has a certain structure and whether it correlates with their understanding, for example. Or I can wonder what if we have different kind of sets that have a different kind of kinematic interrelationships, whether some concepts are more easily learnable for children than others. So yeah, I think there are ways to think about how gestures need to interrelate to be most potent for learning. And we know that language, we always think that we adapted to language as humans to learn, but the language also adapted to be maximally learnable, right? And maybe our gestures can also be more or less learnable depending on how they tend to interrelate with each other. So we could even ask, for example, this data from Yasmin Motamedi. Maybe this is a cool study. We can have this, we know what the kinematic space is, and we allow children to learn that. Which of the ones are better learned and which not? And is that predicted by the kinematic space or not? We can do that experiment in a month. Yeah, so maybe let's do it. Yeah, but I like it. I would apply it to learning. It's really cool.
So any other person online?
Not so far.
I see one person. Julia.
Yeah, hi. Thank you. I kind of come back to the previous question about synchronicity. I was just wondering, because when two systems synchronize, so they are kind of alike, so maybe it kind of increase, because I'm interested in the mutual understanding. So does people understand each other? Because in your data set, we know that they were imitated or trying to describe a specific term, but sometimes in real life, you don't know exactly what people are talking about. And I was just wondering if synchronicity can be a sort of assessment of maybe a better mutual understanding, but at the same time, if two systems are too alike, it kind of buffer the capacity for creativity because maybe they don't explore the kinematic space, let's say. So I don't know if you have any input or idea about that.
Yeah, I think that's a great idea. I think it resonates with how I would think that creativity would be interesting as a domain for research here. That you can say, well, if they're in this kind of attractor or they're just in this really constrained kind of way of behaving, maybe because you're not feeling free enough to use your gestures in a certain way, or you feel like people are often anxious, and I do that sometimes. I just try to mirror people and then and just let it go like that, and then I don't have to think about it anymore. But you would see that in my constrained way of gesturing, right? So I would think that if you have some kind of expansion or reduction of the kinematic space that you dynamically track to time, maybe some kind of windowed analysis, you were right that maybe you'd find that some highly synchronous or similar kinematic spaces between persons is not at all conducive for the flow of the conversation. And And as you know, right, so I think you were interested in cross-wavelet analysis as well. I think that people are moving away that synchrony is always good for social affiliation or anything. You need some kind of more jazz-like emergence of sometimes coupling, sometimes decoupling. Or that's the same, like looking somebody constantly in the eye can be quite intense, right? So you sometimes have to be, you have to have some chaos in your community.
Yeah, definitely, yeah. Thanks, very interesting.
But I like it, yeah.
Can I comment as well? Yeah, just to add to that, maybe as a kind of extra note and something to consider for this as well. I think we mentioned this maybe at lunch yesterday or something, so not part of the Zoom call now. But there is also some evidence for this kind of dynamic happening at the different levels of interaction and communicative behavior, in the sense of, so this is kind of from a framework that Riccardo Fusaroli has worked on and has some published papers on, and some work that I'm now doing with him as well, looking at speech and gestures. That seems like indeed people will have some kind of more synchronous alignment behavior at certain levels. So for example, in their speech, either in the acoustics or their actual kind of lexical or semantic alignment, for example, and complementarity on other levels where they actually diverge from one another depending on the amount of actual kind of shared knowledge that they have. So it seems like this could be something to look at indeed in a very multimodal way, in the sense that if you have this kind of shared kind of space together, it could be that you then start to be able to diverge from one another to indeed have this kind of creativity, this openness that you otherwise wouldn't have. Because if you don't have this shared ground, this common ground, then you kind of need to synchronize and align to make sure that you're on the same page with one another. But just kind of as an extra comment on that, I think it's really interesting because it seems to happen across multiple scales of the communicative behavior, and also depending on the kind of necessities of the conversation or of the interaction overall.
Yeah, definitely.
I could also quickly comment on that because it's very interesting, and also Julia's question. But what we find so far is that if you have full synchronicity, is not good. But we find that in movement, for example, in body acceleration and in that kind of stuff, if they are synchronized, they enter in a sort of flow state. And so that is good for creativity. But then they are kind of unsynchronized in terms of semantic content of their language, for example. And that adds creativity because they become complementary one to another. So they don't overlap totally. So that is probably aligned with your thoughts. Yeah.
I always have to think like the metaphor of, do we represent the world by mirroring it, or do we represent the world like how a key represents the lock? You can reconstruct the key from its lock, but the key is not the lock, right? Whilst mirroring, you're becoming that. So it's more like a fit than a mirror.
If I would tie everything a bit back to the Envision dataset and some of our watching of it, so if we say that there are high-level 2 spaces where you could be playing in that Envision dataset, the teams, there's what we call wayfinding and navigation. And so when people are trying to walk through a forest, they just take note of things that are there because they want to hunt. But there's the part so that's wayfinding. And so the gestures there we see are radically similar and different than when they have to take it back home. And so teams who just spend the whole time also just generating ideas semantically, but also have this exploratory gestures, have different signatures in a sense that at the end, maybe they don't take anything home. They just did a lot of exploration and used a lot of gestures, but they did not also follow it up with concretizing it and saying, okay, we've got that idea, let's move to the next one. We've got that concept, let's move to the next one. So Team 10 has a very interesting energy when you watch them. You see that flow of exploring the semantic space, the kinematic space looks a bit much more in alignment and chaotic than other teams where you see a very long stretch of quietness. And you're wondering why are they not doing anything? Because one person's gestures is not activated, another person's gestures, and if I'm doing this, and I'm asking, so what did they ask us to redesign for like 5 minutes? Everyone kind of falls to that energy level, and so that's what we are also then interested in looking at more in the Envision dataset.
I think the Envision dataset for this is really amazing.
And then Aisley's paper on alignment is also another very paradigmatic.
Yeah, from Marlou Rasenberg.
Alignment, and we would put them in the group.
Yeah, it's a great paper. I work with her. It's great.
Cool.
If you guys look at this is something that James just said, but it's, he said every motion actually has two motions, the ballistic and then there's a fine tuning.
Yeah.
I was wondering if we could begin to think about what the more general the sketchy gestures are, as opposed to the, I got this right, specific gestures. Our language for that is gestalting and integrating, right? And I'm wondering if there's also, when you integrate, there's extreme reduction of complexity in the space, where it is gestalting, there still is a lot of variation.
And playing with the core of the procedure, namely your distance calculation, can make difference more abstract, or what is similar is depending on your values or what you care about. Everything is different and the same depending on what you value about a certain phenomenon. So I think still the form, I believe this is getting some interesting thing out, but I want to have a more structural way, and this is a challenge for this approach, more structural way to abstract away more from just form similarity, right?
Yep.
And maybe more like what Gerard was showing yesterday, these kind of levels of representation. I think that would be really nice to do as a next kind of exploration.
And to be explicitly careful that we don't think of gestures as that they might have alphabets and words, but we have to be really careful that.
Yeah, definitely. No, they're continuous, and what is important is that the context, right? What are you saying? Are you pointing to the body, like the famous example, or am I pointing to the ears? That's defined by the context. So you can look at the gesture or how long you want, but you will never know what the meaning is, because the meaning is not in the gesture. It's always within that context. And gestures are precisely gestures because they're sloppy. They function in a context. They attain their meaning by being parasitic on the environment, whilst our words are much less parasitic like that. Or at least they're so conventionalized that we don't see them as parasitic anymore. But gestures I think this is the core of why we use gestures. It's because they can be sloppy, they don't have truth conditions, they just function within a context really well, because they can grab meaning here, grab meaning there. And I think that's why I'm doing a lot of kinematics, but in the end I think, well, it will be really difficult for machine learning to say this is a gesture or not, because we don't even agree on it, right? And we don't agree on it because it's so parasitic on all kinds of contexts.
Or maybe we find patterns that are common across.
Yeah, of course. Still there are constraints. And you can only move so fast, and you can only move in a certain way. And some ways of moving are more optimal than others.
But miming, we would say, like a mime, Marcel, Marceau, it references more truth value than doing a marking type. Or at least
maybe it's less parasitic on.
Because it really is creating a correspondence to an environment and a context in a specific way.
But for example, maybe we should stop, but we can talk about this further.
Thank you, Jim. Now we have not a coffee break. Lunch break. I said not. So to lunch break, 45 minutes. So we're back at 1:15 German time. Enjoy. You can continue with the questions over food. Andrea, can you give me a gesture?
This one, of course.
Okay, so let's get up and copy Andrea. Let's get up and copy Andrea.
But you have to make it big for the audience in online.
So Andrea has to come here.
Okay, so please follow me.
So Andrea, give us a gesture.
Okay.
And then we copy
This one,
Andrea.
They see me, right? Okay.
So we copy Andrea. So give us another extra gesture that we can copy.
We also do like this when we talk, or
Okay, so we do this and this.
yes. Okay. Yes.
Yeah?
Because we are very welcoming.
Okay. Okay. So Ola, can you join Andrea and give us a new gesture and combine with what he did so that we can copy that?
Okay.
So you can start again, your 2 gestures, and then your 3rd one, and then we copy it.
This was the first one, yeah.
The first one.
Then this one.
This one, yeah.
Yeah?
And this one.
That's a Polish gesture.
This is a Polish gesture, cultural.
What does that mean?
The drink.
To drink?
Yes.
Okay, in Nigeria it means I'm gonna kill you. So Max, can you join the gang and give us another layer, another modality to that, and so we can all copy online and offline. Yeah. So we have this. This.
Yeah, I'm gonna kill you.
What is that?
Cycling.
Cycling. Okay. Does that mean that's running away? Okay. 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 Do we want to complicate it a bit? Victor, can you add?
Okay.
That's the final one. That's the final one.
We started with the first one.
Okay, so starting with this.
Yeah.
Then this.
That.
Then this. Then
Bicycle.
we have this.
And
then we have this.
Try not to sleep.
that was exactly the opposite point I wanted to make.
That was great.
Okay, so we're going to extend the general approach that we just had, and we're making it multivariate in the sense that we're going to look at sets of gestures that multiple persons are making. So within the Envision data set. So I'll share my screen real quick. So one thing that we have done in the past, for example, is looking at not only single individuals that are producing gesture, but also, for example, looking at people who are talking about particular objects. These objects don't have names. These objects need to be named over and over again so that somebody else can identify it, and these are called fribbles. And we have 2 persons. Yeah, I'm going to show you here. Yeah.
You said the name was called what?
Fribbles.
Those are fribbles.
Yeah, they're called fribbles. Okay. But what if I need to communicate to you? You have another screen, and I need to communicate to you. Well, I want you to see this particular object. It has like 2 fists in front of it, and something like an antenna on top of it. Now you need to identify it from your side. So, and I'm gonna name it. At a certain point, we're just gonna give it a name. Probably, I'm just gonna say, hey, this is the boxer, right? But first, I'm gonna start with geometrical description. So, what happens over time? That's a study that was performed by a large consortium at Donders. And what we did, for example, is look at, well, what are the names that are being produced at the end or at the beginning, where one person is saying, well, this is a boxer. At the beginning, somebody who hasn't interacted yet with this person will have different names, right? Maybe I call it a boxer, but you call it a kickboxer, or I don't know, whatever. And you can compute semantic distances from this. Well, how different are they, or how likely are they to occur in a similar context within a corpus, right? That's how these word-to-fact kind of distances are produced. And we also have the gestures. So what are the gestures that are being produced for a particular fribble? And if we compare that between persons, what is the kinematic distance based on the dynamic time warping? And we found, for example, at the beginning, the pre-semantic distances weren't correlated with somebody else's kinematic distances between these persons. But later on, their gestures became coherent in a way that also reflected their semantic distances in calling these ripples. So this is just one extension, right? But we have different extensions too that are possible. So, oh, I can share another time, sorry. Let's go into the Envision dataset. This can go. So for the Envision dataset, remember that we have 3 persons redesigning a particular, well, what do we call it? A particular product? Yeah, product. And we also had a lot of codings from Jonathan from his PhD thesis, right? So we have a bunch of codings here, annotations, with particular begin and end times, and a coding, for example, gesture enactment and pointing stim, right? And we had this whole video, but we were only interested in these specific events. So what we did is we cut out part of the video and took that particular event and did some motion tracking on it. And I'll show you here. These are, for example, this is one event. And these are more than 1,000 events. Not all are really good tracks, so we will filter some out. This is a writing, for example, a writing event. And here we have, all kinds of events, touching event, right? So this is filled with 1,000 different kind of events within here. And I'm using a script that's also in the, I'm using a script that takes the annotations. Is it this one? Yeah, takes annotations and then clips the video. So you can use this as well, but it's not as exciting, that particular code. So we have all these kind of events, but there are multiple persons, right? So for example, this is person 3, but we also have person 2 producing events and person 1. And again, we can do these gesture network kind of analysis, right? So let me show you what I think, what is important for this particular module too, is that we're working with a little bit more messy data, right? We're not having this actor doing the same kind of movements, and this is much more messy. Some of them are not amenable to analysis because the tracking was not good. Some things might not be interesting in. Do we really want to compare writing events, for example, or only gesture events? So let me go to the module 2. So one of the problems that we have with this particular data, again, we're loading in the data here with the folders. We're not going to go into that, right? We're just identifying all the relevant folders here. But there were particular problems. What if you have a right-handed gesture and a left-handed gesture, you want to compare them? You want to say that this gesture or this gesture is the same as this gesture, right? So one thing that we'll do, we'll take a gesture. If it's a right or a left hand, we're going to mirror it. The left hand, we're going to mirror around the vertical axis, so we can compare right and left-handed gestures. The motion tracking wasn't always that nice, so we said, well, at least give me, I'm only going to analyze files where at least 50% of the time we have a left and right hand detected. What else do we have? We're not going to look at all kind of action types, so we're going to filter some out. Another issue is that we have these gesture events, but we don't know if it's a left or a right-handed gesture, so we need to have some kind of rule that says, well, I want to have a gesture event and then identify which hand was moving the most and take that one, and if it's left hand, mirror it, right? So that's a good bit of portion of the code that's actually produced at the beginning. And I am not too sure if I will go into that because it's not as fascinating, but let me just say maybe at the beginning that here in this particular piece of code, we say these types we don't want to look at, features, scaffolds, usability. I'm not too sure which ones I wanted to exclude actually, but then we have a pre-process function where we say, I have some data, I want to interpolate the data where we have missing values. Well, we already have done the interpolating, right? You know how it is. Or you know how that goes because we've talked about that before. Here, for example, I'm mirroring the left hand where we say I have an x value and an x value. I'm going to mirror it by multiply -1, right? So we mirror it. And these kind of effects, what you actually end up with is a bunch of files that are amenable for analysis. And here is an example of a gesture that is produced with the right hand and the left hand. And again, I always advise to do some kind of checking whether everything after your pre-processing has been done. We smoothed it a little bit. We use some interpolation between missing values. And this I've also entered in a script which you can use where you plot all the points that are occurring over time, and you can actually have videos that are de-identified, right, anonymous as well, and you can check against the data. It's quite straightforward. You can tinker around with this code. I don't think we need to go really into that. But here's an example. The most tricky is not that great. Again, I want to use suboptimal data to show you that at least still it does make sense for whatever we have, right? Like in your first example, I didn't even do smoothing, and you saw that was picking up quite nicely. I want to also show you some robustness of the results. And here we see somebody primarily using the right hand, and our script identified that gesture, at least that was the moving hand. Here it's a left hand that is moving most, and you'll see that it is mirrored, and now it can be compared to this one as well, right? So we can use kind of dynamic time warping in this instance as well, and we can compute this. I have made slight changes this time to our main operation. I'm using a slightly different dynamic time warping approach, where we say we have just a hand, and I'm going to compare all the key points velocities, and I'm going to compare it to the other hand. I'm going to use a particular dynamic time warping algorithm where I don't care about the begin and end time so much, because often you don't know when something starts. It's not as, you want to say, well, the middle part is probably the most important part, and don't allow your errors to be very high at the trailing end. So I'm doing that particular kind of dynamic time warping, which has been shown to be more robust. So I'm also adding these things. So compare that with module 1 and module 2. And we're doing the same routine actually, right? So we have a slightly different dynamic time warping where we are producing the same, where we use this separate kind of dynamic time warping. We're producing it forwards and backwards, because if you have this particular version, it depends on what you set as the referent and what is the query. And then, but we are doing it backward and forward. We're using all the key points of the hands, because we're really only interested in the hand here, where we have information about the hand. And then this is something you will just recognize from module 1. We went through this. We now have all these different events. We went from 1,000 events that were potentially amenable for analysis to like 100, because the motion tracking wasn't that great, and that's why James wrote an extra script, which I haven't applied on this data, to improve the linking a little bit. So, but I haven't applied it here. But then we would have more data if that would be applied. And we're again looping through all these time series data, and we're computing these distances this time between the velocity of all the key points of the hand with another hand. And the visualizing results is again the same. I'm using a different kind of dimensionality reduction technique. Instead of classic multidimensional scaling, I'm using t-distributed nearest neighbor kind of analysis, which is more, it's nice to maybe force a distance matrix to show clusters, and it's always a little bit distorting. But remember, we're always doing computations on the distance matrix and never on the kind of visualization techniques that we're using. And yeah, I think I'm just going to show you what the difference is between what you can do now if you generalize this to a multivariate situation. Namely, again, we have now all the codings by Jonathan, and we can look, for example, and select which ones where a particular hand movement, how it was occupied in space, right? And generally see, for example, that the touching movements were all kind of idiosyncratic. They were kind of lumping together, but if you have maybe a G level, it's much more expanded. So the difference is, well, of course, the touching is now communicative in and of itself, maybe, or it can be communicative, of course, but the enactments are much more, they're making much more creative use of kinematics, right? So this is something where Jonathan and I were talking about, well, maybe this is something you can also use as a qualitative way to say, well, I know that there are different kind of concepts that I think that are different, but how does that relate to the kinematic space? And not always they need to relate, but if they do relate, you can make some inferences of why that is the case or not, right? So again, use these plotting functions to dynamically loop through all your codings that you have and see whether they make sense in the kinematic space too. So another thing that you could do, for example, is say, well, this isn't the most visual, I should improve it, but you could, for example, say, well, what happens if I connect every dot in time? So I have a gesture event at second 2, but at next one, I have at second 3, and then make a connection between them. You can see how throughout this team dynamics, how you traverse the kinematic space as you go, right? So it might be at certain moments you jump from one place to another in the kinematic space, but it could also be that at a certain moment you kind of settle on an attractor, for example. You get little like small points where things settle on. And I think if you want to improve this code, maybe we should color the geom lines or the lines with a color that goes from yellow to red, for example, and then you see where it's settling on. But also notice here something else. We've now colored the persons. So we have a participant 2 who's gesturing a lot, and a participant 1 who has a couple of gestures here and there, and a participant 3 that's more here. We can ask, for every team, we can start asking about what is the general position of the gesture nodes of participant 1, and what is the general position or topological location of person 2. And I hope in the semantic analysis, much of the measures that you're using can be applied to this kind of thing as well, right? Maybe the centrality or the small worldness of this particular network, or within individuals or between individuals. So again, we can visualize this particular matrix here. And again, it's creating an HTML file where we're producing all these hand movements, and we're plotting them according to the TSNE dimensionality reduction algorithm. And here you see, for example, you have this particular gesture that are dynamic, or according to dynamic time warping, quite similar. You have this kind of movement. Here you have like a pronation of the wrist, like this, and these are much similar in space. Well, this is something you are familiar with right now, but it's again nice to look at the particular result multimodally. And then I thought, well, maybe there seems to be some kind of convergence here. So you can ask throughout time, what are the steps from what is the position in a kinematic space from one gesture to that one that followed? And is it the case that it's always the same like distance between you traverse this kinematic space, or are they converging at the end? So I'm just now I'm going to plot the time from 0 to the end of the conversation. I'm going to say, from every gesture from one to the next, was it always the same distance, or is it correlated, such as, for example, at the end, people start to converge and you're actually not moving throughout kinematic space that much. So that's one of the questions that we can ask. And remember, we have this distance matrix of, let's say, 150 gestures, and each gesture's location in kinematic space is defined by these 110 or 109 minus itself, right? Those are the dimensions. So we're asking, what is the Euclidean distance between one point and the next in this 110 dimensional space? And what is the kinematic space that is being traversed? And what is interesting, maybe, and fun to follow up on, is here that we see that in the beginning there is much more traversion in the kinematic space going from one place to the next in this, but at the end, they seem to converge. They seem to show that at the end, maybe you have a kinematic dialect that you have, or you have some common ground that you're building, and you don't have to use the degrees of freedom anymore to show something creatively or make it done, or but you could wonder, what does it mean for different teams having different kind of structures throughout time in how they move through the kinematic space or not? So as we go, less kinematic distance is traversed by these teams, or in this team 10. Yeah, we need to apply this to all the teams at some point.
Is this all 22 minutes of what they do?
Yeah.
Okay,
yeah.
so this is a 22-minute thing.
Yeah.
Wow.
So sorry, the time is now in milliseconds, so it's a really large number. But that's one of the things that we could do. I think that's it. It's just another application that you can generalize quite fast to more persons. We don't know. I don't really go into much of the kind of analysis that we can do on the distance matrices or how you compare between persons. I think for now, this is you need to have understand this general process, and then you are free to do whatever you want with it, right? And try to operationalize certain qualitative concepts with this. And yeah.
It's now what I want to do is put this plot as I watch the video.
Yeah.
This moment and this moment. And I know these are generalizations, but that's fine. And here's an area where, for example, just a little bit in from the left, it's this hugely, it's a hugely broad space.
Yeah, definitely. And you can also wonder, why is this one so far? What was the function of this gesture that it needed to traverse the kinematic space to such a degree that it, you can ask qualitative questions about this. And like I said, I think this analysis is not only interested for really quantitative-minded people. You could also ask, well, we know that this has some kinematic distance, and how did it function if I look at it, with knowing that this was actually something that was quite unique quantitatively? Was it also unique qualitatively? That's a question.
Yep.
Yeah.
This is wonderful. Thank you. Christmas happens every day.
Yeah. Any questions? Are we good on time, James? Yeah? Okay.
So any questions in the audience, virtual and physical?
So does emergent concept generation correlate with reduced complexity in kinematic space?
Mm-hmm.
Well, maybe. Amazing. Thank you. Oh, no. Yeah.
I think while we're getting James ready, my personal reflections also about how sometimes the hypothesis and the questions might change after you've done a bit of tinkering and visualizations, and then you iterate and go back to what you thought you wanted to know.
Yeah, absolutely. I think the other thing that both James and Wim have emphasized that it's really important to keep in mind is go back to the data. Now that you have this insight, what's going on at that moment and vice versa? Because that's a gigantic, what I just saw is gigantic, right? Look at what happened there. So what was it that was happening, right?
Yeah.
And, eventually my Stanford cohort we want to say, what's the slope? What's the slope? What's the slope? How does that work? Is that something?
We as cognitive scientists sometimes forget that sometimes we work with measures that are quite abstract, and it's really difficult to point back to the phenomenon.
Yeah.
So, it's easy to forget because you can get lost in it.
And then the next level for me would be, now can I teach that? Behavior.
Yeah.
Right.
Cool. So,
All right, it's great. Yeah, so kind of the theme of this this last module for me is going to be the last couple things I've talked about in terms of analysis has really been focused on taking discrete kind of moments or things like a particular gesture or an utterance, and then trying to quantify that, and then getting a summary of stuff that happened. And what I think is really interesting, something that I've really been challenged to do working on this Envision project, is also to think about the kind of the complete picture, so the dynamics of what people are doing together, and kind of thinking about the interaction as one thing, essentially, rather than just saying, well, they gestured to this moment, what did that gesture look like? What did the next one look like? And so one way to do this, I think there are a couple of different things I'd be interested in doing, but one way to go about this is to look at the turn-taking behavior amongst the different participants. So just to kind of situate this a bit before I go into the code, I wanted to kind of just give a short overview. This idea that turn-taking is one of these fundamental aspects of human communication, human interaction that we engage in every day in terms of we speak with one another. I'll say something, you'll say something, and there's this really quick back and forth between us that's really quite remarkable, where there's a fairly minimal gap between the end of my utterance and the beginning of yours. And what research has shown is that this gap kind of clusters around 0 milliseconds, with about 200 milliseconds around that, which is incredibly fast. So to kind of put that in perspective from the cognitive scientist in me, just for you to, if you see a picture, something very recognizable, a dog, and you need to, when you see it, just say dog. The amount of time it takes you to create this utterance and produce it is on the order of 600 milliseconds, which means you're already planning your utterance in parallel to hearing the other person. So it's a very fast dynamical system. And this is something that's been also looked at across many different languages. And while there's some variation, it is quite a stable thing that people are very, very quick in this turn-taking behavior. So just to kind of give you an idea of how we can actually start quantifying this, the way that I'm going to do it is on this 2-second kind of threshold. So it's essentially, what I'll be talking about is the turn transition time. And that can be broken down into gaps, which are positive values. So there's some sort of lag between me stopping, you starting, and overlaps. And these are the negative values where there's some short overlap. And this is quite fine because on this order of, say, 200, 300 milliseconds, you don't even notice that there's overlap. It seemed like kind of perfect transition. So this is all kind of okay. But just to give you an idea that these are the kinds of two sorts of values that we can have. So one thing that I thought was quite nice also in relation to collaboration and this type of work, there's this paper that already suggests that if you look at the turn-taking behavior of children performing different tasks, they seem to show smoother turn-taking patterns when they're doing something collaborative rather than something kind of conflictive. So there does seem to be something about the actual teamwork aspect of what you're doing that is also reflected in the timing of your turn transitions. Similarly, I've also looked at this from kind of a multimodal perspective. This last one was just in speech. So this is, I'm not going to go into it too much, but we essentially did this study to see the effect of visibility of the visual articulators during just free conversation. So we had these different grades of blurring while people had this, this conversation. And we looked at what that did to their turn-taking behavior and to their visual signaling, for example. And so just as a starting point, we already saw that as the visibility decreased, we saw larger and more segmented gestures. So this is kind of relating back to this last module that I showed you. We were able to capture this dynamic aspect across the interaction. And we also saw that with the visibility, this also affected their turn taking. So there is less overlap when gestures were present. This was particularly when it was moderately visible. So there's already this interaction between the turn-taking overlaps, let's say, and the use of visual signals.
So does that say that just to be clear, is that saying that there's more overlapping in the middle than there is when it's absolutely clear or absolutely blurry?
So there's actually less overlap in the...
There's less overlap.
Yeah, so sorry, on the y-axis here, we have less overlap on the top. So this is kind of thinking of two plots where you have, if you were to think of the 0 being in the middle and overlaps down here and gaps up there.
Okay.
Yeah, exactly. Yeah, so yeah, I basically just wanted to kind of show that as just a kind of introduction to this. And we also see that the visual signals kind of interact with this turn-taking behavior, and this seems to kind of affect what people are doing. You also see that the kind of larger, more segmented gestures people produce, this also leads to less overlap and shorter gaps between the people. So just to kind of contextualize this, like I said, I don't want to go into a whole kind of overview of this work right now. So, right, so what we're going to try to do here is capture some of this turn-taking behavior and see if we can do something with that. The packages I'm going to use are PyMPI again to get the annotations, and towards the end I'm going to use entropy to look at entropy in their turn-taking behaviors. Yeah, I have a short note on this. Basically, what we're using for this turn-taking behavior is manually coded utterances that we have from this Envision dataset. So we don't have an automatic annotation, but it is possible to do this, and there is code available from this previous study that I did. If you have, for example, 1 microphone per person, you can automatically extract the utterances rather than manually annotating it. And there are just some kind of tricks to doing that, filtering out back channels, etc. But I won't go into that right now. So let's get right into this. The idea basically is that we want to be able to calculate the gaps and overlaps between utterances, right? We have a series of these annotations, and we have 3 different people who produce them. So what we're going to have, we have utterances 1, utterances 2, utterances 3. This is just a series of onsets and offsets from each person, from them speaking, essentially. And then we're going to set up just some lists that we're going to then fill with our individual values. And what we do here is we just start looping through utterance 1 from person 1. And we're going to start looking for the offsets with the other 2 individuals. So this is essentially saying, okay, we're at the first utterance of this speaker, and we're going to look at now when the other speakers start their utterances and basically just find the minimum value there. So it could be that it's very, very close. And then we know, okay, this is probably the kind of next turn transition that we're making. The ones that are further away already get kind of sifted out in this initial process. Now, of course, it could be that 2 seconds after I've ended my utterance, you say something, but actually I ended, but then I said something else in between, and we don't want to catch that. We actually want to then move on to the next one and get that turn transition, because that's the real one. And so we also look at the kind of minimum pause between this utterance and the next one, just to make sure we're kind of making sure this is one speaker to the next and not getting mixed up there. And then we're going to also put this 2-second limit on it, because basically the idea is on this kind of thinking, it's from a Hildner and Edlund paper, essentially that we don't want to have the I've stopped speaking, there's kind of a pause, maybe a change in topic, then you start up, because this is just conceptually, it's maybe a bit different than a back and forth, essentially. Once we've gotten that, this is just going to give us a list of the turn transition times overall. Then we just go through, very simple, if it's a positive value, we're going to add it to our list of gaps. If it's a negative value, we're going to add it to our list of overlaps. So then we just have a couple of different lists. And of course, I started this out with, well, speaker one and then the other two, but we actually need this in all directions, right? This is the complexity of multi-person turn taking. So that's what this bit of the function does. We're essentially just going to make sure we know how many speakers are in here, so we know how to do it. And then if there are too few, so if there's just one in this particular video, shouldn't happen in this case, but it's just kind of a catch to think about. We're then going to go through and we're going to apply this function that I just showed you in basically the 3 starting people. So starting right up here, we'll start with person 1, and then we have utterances 2 and 3 as the ones that we'll kind of check against. And then we'll go with person 2 with 1 and 3, and then person 3 with 2 and 1. And the ordering on these really doesn't matter too much, because the whole idea is that as long as we have a sort of centering point for this first speaker, we're just going to look at which one comes next. So it doesn't actually matter which order we put the other 2 into our function. The point is that we're going to get the turn transitions from the point of view of this one particular person. So what we'll do after that is, in this function, at least, we're going to collect all of those and just have this additional function, which is down below, where we'll show the turn transition statistics from the point of view of each of these individual speakers. So this is just to give kind of a rough numerical idea of what's happening in the data. And then just a couple of extra transformations here. Basically, we're going to put all of this into one data frame. So we need to basically make a list of, this is all speaker 1, this is all speaker 2, etc. And in the end, we get a nice data frame out of this. And then this is also, it's not very exciting code. The only thing it's doing is taking this data frame, and we're getting essentially the mean transition times, the standard deviations, basically just giving you a block of something to say, this is what's happening in this particular person. So this is what we'll do. Like I said, we're using one of the files from the Envision dataset, group 10, and we're just going to use that file. We're going to use the annotations where we have the utterances coded, pull that in. We'll use list comprehension here to make the different lists. This is just saying, okay, for each annotation in this file, just put it now in list format. So just kind of a way of reordering the data. And then we feed it into this one kind of master function that I have that's going to do all of the other things for us. Create one data frame that we can then do our analyses on, as well as print out our statistics. So this is already done. I went ahead and ran it. And what we're going to see here, we'll just take kind of a moment to walk you through it a little bit. We'll have participant 1 right here on the start. We'll have participant 2 and then participant 3. And we'll have all the individual values below it. So this is also to give you an idea of what exactly is happening, right? So we have, for example, for participant 1, we'll focus on this for now, the mean turn transition time. This is in milliseconds, and it's 4 milliseconds. So this is why I want to look at the gaps and the overlaps, because this is almost 0. So this is quite short. But if we look at, for example, the gap mean, we have 439. If we look at the overlaps, we have 560. So what essentially is happening is they're going in opposite directions, of course, so then the mean collapses down into the middle. This is quite fine if you're just interested in kind of the smoothness of the turn taking, where is it? But that's why it can be nice to have all three values, because then you do have more of a sense of what's going on in terms of how far apart, how much gap is there between speakers when there's a gap, how much overlap is there. And splitting this apart between the different participants can also give you some idea of how it might differ between individual within this group. So for example, is one speaker having kind of longer gaps, they say something and the other two maybe sit and think about it for a moment, is always very, very fast. Is there a lot of overlap? So every time one particular speaker goes, are they being kind of almost interrupted or having more? We already can see that with speaker 3, they seem to have almost 700 milliseconds on their overlap. So it seems like they actually have a little bit more kind of overlapping speech from the other two than the other two do. So this can be interesting. This can be something that you can already look into. This already gives us a sense of this kind of smoothness of the turn transitions across the interaction. What we can also look at, which is kind of the classic way of plotting this, like I showed above, we're just going to take these turn transition times, so not the gaps and overlap separately, all of it at one, and then we can just plot it like we have here. So this is just another way of showing what we were looking at before. It's again, checking your data to make sure it makes sense. We've seen what this kind of cross-linguistic study has shown, where we have this nice kind of plot going around 0. And we can see pretty nicely for this data, even just looking at these 3 participants across the interaction, we again see this pretty sharp accumulation right around 0, where it is pretty smooth turn transitions for them. So this just kind of shows there's nothing too weird in the data. There's no weird kind of spikes at the end or at the beginning showing that there's a lot of overlap or a lot of gap or anything like that. But this can also be something quite relevant in and of itself, because essentially this, what you can do with this is then look like this example of the collaboration versus conflict. You can already start using these turn transition times to start comparing, for example, across groups. Does one of them have a smoother turn transition time than the other ones? Is it closer to 0 with, for example, shorter deviation? Is there less variance in it? You can also, for example, look at comparing or correlating these values. I think I have it down here. Summarizing them and correlating with other information. So the chi-scores that you might have, you might also have some other aspects of the group that actually just summarizes the group behavior or their performance or something, and ask questions like, okay, if they have a smoother turn transition timing across their interactions, are they also performing better? Are they doing this? Are they doing that? And already start to kind of check what this says about their overall performance or their overall behavior. So this is kind of a simple starting point for doing this. Another thing that we can think about is, rather than taking these raw values, we can actually look at the entropy of the turn transition timing. So the entropy is essentially asking how kind of variable or predictable is the signal over time. So this is that idea, like I said, instead of taking kind of pinpointed thing, but let's look at the whole thing and its kind of summary behavior in a way. Yeah, so I have this kind of example that in a perfectly stable back and forth interaction, each turn transition could be approximately 36 milliseconds, let's say. And then you would get a particular mean, standard deviation. And essentially, if you have this, the next value, if you go from one turn transition to the next, should be quite stable, actually. It's very predictable. You kind of know what's coming next, right? So that would be a low entropy. But if it's kind of all over the place, sometimes it's very quick, sometimes it's a much longer gap or an overlap, then you should have a higher entropy. So that's what we're going to try to get at here. So what we first do with this block is to take our data frame, which originally was split up for each of our individuals. And now we want to say it's about the interaction. So what we're going to do is we're going to order it. So rather than caring about which participant is first, we just have a participant value. We have a timestamp value, and we have the transition and utterance duration. So you'll see basically the point here, the timestamp is the one that's kind of moving up. So what this would mean essentially is that the first turn transition in our interaction is from participant 3. They were speaking And then there is a transition duration of 520 milliseconds. The next one is with participant 2, who's currently speaking or was currently speaking, and the transition from them is 690 milliseconds. So this is basically just a time series across the whole thing of each transition from one speaker to the next. And we have, importantly, I would say, essentially two aspects of data that I think can be quite interesting here. One of them is the ordering of the participants, who's speaking and who's speaking next. And the other one's the transition duration itself. Like I said, how variable is that? And we can already start looking at this a bit. So this is what I've plotted here. The first one is the turn transition time across the entire 20-minute interaction. You can see it's very squiggly. If we look at just kind of a section of that, just to kind of zoom in so you have an idea, you can also see that it's fairly variable, essentially. You'll notice they're not equidistant apart because this is still based on the timestamp. So it could be that there's a long utterance in between, it could be there's a longer gap, etc. But basically the idea is we have this time series that tells us something about from point to point, and let's look at how variable this is overall. And so what we're going to do with this is to calculate the sample entropy, and that's what I was just talking about before. This is essentially just saying how predictable is this over time? If we have a value here, how easy is it for me to know what exactly is going to be the next value? And if you never have any idea, because it could be really high, it could be really low, it could be in the middle, you should have a very high entropy. If not, if it's kind of stable right around 0, you pretty well know it should be approximately, then you'll have a low entropy. And so we get a nice value for this. Again, this is like some of the stuff I showed with the other analyses. The value by itself isn't going to tell you a whole lot. It's not going to be that you say, wow, you have an entropy value of 2, so yeah. But again, if you have all of these different interactions, you can then start asking, okay, well, which groups have lower or higher entropy? Does this tell us something about their performance, about the people in it? We could also split this into different windows and see what is the entropy across at different kind of sliding points in the interaction. Does it change? Is the timing kind of changing its dynamics as the interaction unfolds? Sky's the limit, essentially, but this kind of gives you an idea of how variable this aspect of their dynamical interaction is playing out. Another aspect I alluded to before is thinking about the ordering of the participants in this kind of turn transition dance, as it were. And to get at that, we can use permutation entropy. This essentially is looking at, well, the ordering of the ordinal values in or the categorical values in the time series. So essentially, this is the complexity of who is following whom. If we say, for example, in an interaction, speaker A speaks, and then speaker B speaks, and then speaker C, and then A, B, C, and it's always this kind of, again, this is a very predictable signal, right? You basically know if A is speaking, B is probably going to be next. Even if C sometimes comes in, if it's really like that, you basically know the entropy is going to be very, very low. If it's a perfect kind of back and forth or kind of around in a circle, then the entropy should be 0 because the signal is perfectly predictable from one value to the next. If, on the other hand, you don't really know, speaker A is done, you don't know which of the two will come up, then the permutation entropy should be much higher. So this is kind of capturing this aspect. And what I think is interesting about this is, again, looking at different moments even, and say, well, if it's, it could be that in a very stable part of the interaction, they're kind of going back and forth, it's fairly predictable who's speaking when, then you should have a low entropy. But maybe when you get into this kind of a breakthrough moment or something, and everyone starts kind of going back and forth, it's a rapid exchange of ideas, the entropy should peak. And so what this little block of code, it's very simple because really this entropy package is doing all the hard work for me right here. I'm just going to take these windows for this example. I'm going to essentially break the video down into 4-minute blocks just to see how the entropy kind of unfolds over the course of the interaction. I've written it out here basically just so it's easy to see how this is being done, milliseconds, minutes, and etc. And we're going to just make windows across this. So saying, well, what are the timestamps here? What are the timestamps for the beginning of this 4 minutes, the end of this 4 minutes, the next, etc., etc. And as we go through, we're just going to have this list of values where we calculate the permutation entropy in this window using the participant value. So this is basically just saying which one it is. So like you saw in this is just this number. So is it participant 3, 2, or 1? And this could be essentially any number of participants that you have. That's all quite fine. The point is that you have several. One thing to mention on this particular approach is that you do need to compare this across equally composed groups, let's say. So if you have like a group of 3 people and you have a group of 5 people, you cannot compare the permutation entropy across them. It will be a different calculation. So it has to be equal number of groups of this. The number of values within it shouldn't matter as much, as far as I'm aware. Yeah, so that's just that. We calculate essentially, and then we just move the window forwards. Then the next one starts at the end of the previous one. We take our window length, which we defined at the beginning, and just add that on, and we just loop through a few times to create these points. And so that's what I have plotted here, just going across it. I've kind of shown these, this is like the minute values, so minutes 1 to 4, 5 to 8, etc. And these are the permutation entropy values for each window. And so you kind of see the first, say, 12 minutes going across here, we see the entropy seems to go down, which could be then the beginning of the interaction, kind of speculating here to think about it, maybe get you inspired to think about it more. But it could be that you've kind of start out, you don't really have a team dynamic yet, and then you kind of get into a rhythm of who speaks when and kind of how this goes about. And it could be these moments where it then spikes back up. Is, like I said, something like a breakthrough, could also be a change in topic, but some sort of change in the dynamic of the people that are involved here. And so this is something you can use either as a visualization, perhaps, just to see how are things kind of unfolding, where might there be an interesting point in the interaction where something's really happening. But you can also use this to calculate certain aspects. If you know there's something happening around this point, can we capture that with the entropy, for example? Yeah, so this is, like I said, this is kind of just an introduction to this, to give you the idea of turn taking and some of the things that you might be able to do with it. Getting at just the numerical values of the turn transition times. We can look at the kind of variability. What you do with that in the end is, yeah, it's kind of up to you in terms of what might be interesting, how you can relate it. I think there are a lot of possibilities for this, but I think it's a cool way to capture the sort of dynamical coordination of human interaction in this way. So yeah, we still have some time for questions, so I'm happy to answer anything anyone might have at this point. So I'll go ahead and stop sharing so I can see.
So are there any questions or which questions are there in the audience here and online? Please, you can raise your hands or speak up. Our virtual audience is here as well.
Everyone either needs to really digest it or is so clear they're like, nah, this all makes sense, yeah. Turn taking, entropy, yeah, got it.
I'll ask my question after Joaquin. Hi, thanks James for the presentation. So I was wondering, so turn taking could be highly regulated. For example, when you have time specific for who's talking at what time. For example, in my case, I can imagine a trial in court where each person is given a specific time to talk. And then we have others which are very unregulated or spontaneous. However, even those, so for example, the design interactions that we have in the Envision dataset, they still have some implicit rules on how to interact. How do we account for those in experiment or in different situations?
Yeah, it's a really good point. I think that's, again, one of those things where your design of your study should absolutely control for that, in the sense of you should really kind of compare, well, either compare within a type of interaction, or if you're specifically interested in that, then kind of block it and really explicitly make that comparison. Especially if it's structured, then I can imagine, for example, the permutation entropy isn't really going to be very informative because you essentially know it's a structure, unless you want to know what the structure is. But it could be there's something informative about the turn transition time itself in terms of how fast or how smooth it is. Maybe that changes by something else within it. But otherwise, I would say that's definitely something that should be kind of an explicit condition in how you do this, because it definitely will be affected. Yeah, it's a good point.
Gregor has a question.
Yes, Gregor.
Thank you so much. We're working on an empirical classroom research. So, and I'm wondering, of course, if you have like a school setting with a teacher and lots and lots of students, then it would be, of course, if you have a teacher who's just talking nonstop and not really engaging the group, then I guess you have low entropy. However, if you have somebody who's like calling on people and making it an engaging experience for the students, then you would have higher entropy. And I'm wondering if you would see, for example, applications for this in pedagogical contexts.
Yeah, that's really, really interesting. I think indeed you could kind of think of this, and it's actually one of the things I was thinking about for this module, if I could incorporate it somehow to capture the kind of, say, leader-follower dynamic that might be going on. If you can capture that in a loose interaction, is there some person kind of dominating and coordinating the interaction, would already be quite interesting. But indeed, also, if it's just that there is a structured kind of leader, are they always kind of bouncing back to the other people, or is it really just them and every now and then they're interrupted and then they kind of come back again? Or do they give the floor to the others? I definitely think this could be something really interesting to look at. You'd have to definitely think about which aspect might be most interesting, whether it's the dynamic of who goes after whom, or if it's really about the timing. But yeah, I definitely think this kind of idea of the dynamics, like the kind of power dynamics, if you will, is something that could be really interesting to look at here. Absolutely.
So you have Julia?
If Julia would allow me, I would like to follow up real quickly, because like for classroom research is often what you can do is like you have one mic in the classroom and one contact mic for the teacher. That's the most affordable setup. Would that maybe do and already to like get at least the turns of teacher versus other? Because then this would be like a really powerful and affordable tool for classroom research.
Right. So what I can say, there are some automatic kind of speaker detection models that you can use. Also in ELAN, you have some algorithms that you can apply to kind of take one audio file and split out, and it basically uses these kind of acoustic measures, like a pitch and different things, to say, yeah, this is speaker A, this is speaker B. If you have, for example, two females or two males, it's not super reliable. At least like maybe if you really tune it, you could make it work. I couldn't. But if you have, for example, a male and a female, they have kind of distinct voices, then you can split them apart. I can also imagine adult child. In principle, you should be able to do that, and especially given that one of them, at least on one of the audio signals, should be much more prominent. And in that case, you should be able to split it out automatically and then use some of these tools also to just do this automatic utterance segmentation, detection, and then, yeah, then it's there. Yeah, so I can't promise anything, but I think there's some potential there for sure. Yeah. Julia, yeah.
Yeah, in fact, yeah, I mean, I think my question was already answered kind of. It's probably also my question was about this idea of overlapping. How can we maybe disentangle the influence of each individual? Because maybe, I don't know, somebody, let's say, start a bit quicker when I finish. I noticed that especially in Zoom call, often we tend to speak, but it's not with everybody. Some people have the tendency to speak at the same time than me. And I would like to understand, this kind of leader-follower. And I was just wondering if your analysis, if it's possible to identify, the leader, let's say, the one who is like literally, kind of putting the pace of organizing the pace of the conversation, let's say.
Yeah, no, it's definitely a really good point. And I think it should, in principle, be kind of trivial to add this information. For example, when we calculate the transition dynamics up here somewhere. So here we're calculating already the transition durations, for example. and we know we have an ID for who was speaking then, it's quite simple. If we pick out, we know who the overlapper or the gap person was. We can also add that to just say in the same data frame, it was speaker 1, the next person was speaker 2, and then you can use these same kind of statistical tools essentially to pick out not only who the current speaker is, but you can also filter from the second column and say who is the next speaker with this transition duration. Is, say, speaker 1, are they always associated with much longer overlaps, for example? And then you already have some idea of that dynamic. So that would be one way to do it. Like I said, there's probably sophisticated ways to do like a kind of leader-follower type thing, or kind of power dynamic in that sense as well. But offhand, that would be at least a way to get an idea of the specific transitional behaviors of individuals, indeed. Yeah.
Well, thanks. Sounds very interesting.
Hopefully that kind of gives you an answer.
Yeah, definitely.
Yes.
Yeah, related to.
That might be related to these other questions. I think I'm probably audible, but related to these other questions. I'm wondering whether introducing, I mean, it would require additional annotation rather than working with what's already there, but introducing linguistic function. So whether the interruption is a genuine interruption, sort of, I'm going to speak over you now because I have something important to say, or whether it's like a continuation, an agreement, those kinds of things.
Yeah, no, really interesting. And I think one thing, so probably if you want to have it really perfectly cleanly worked out, best way to do it is indeed manual annotation. But I do know also from turn-taking behavior that if it's an interruption, it should be clear from the timing of the overlap, because like I said, really short ones, on average, people don't notice the short overlaps. So it's these longer ones should be the actual kind of intentional, I'm speaking over you. And the next speaker, you should see a sort of peak raise in their amplitude of their voice in the beginning. So for example, if you're speaking, I think you're about to be done, and so I jump in, then my speaking voice should stay about the same throughout. It's basically what you'd predict if you have an average of my speaking amplitude. But if you're speaking, I think you're done, it's time for me to like jump in, then you'll have this kind of raise in amplitude, and you should be able to pick it apart, I would guess, from these two things, where I raise my voice and I'll overlap more than I would do if I was actually just trying to kind of seamlessly go off of the end of your utterance. So in that sense, it may be also one of those things to do it a few times, or kind of see if you can algorithmically do it and have a couple of manual annotations and just check, does this work out for an automatic detection? But I think there's some pretty strong cues for it, at least.
Thank you. So we have one question also in the chat from Alicia Jans. And since she typed it in, I'm going to just read it. Could you elaborate a bit on how your backchannel detection works?
Yeah, I can definitely say that it's a very crude measure. So we basically have taken these studies that show the average duration of back channels, wanting to say that they are on average less than like 200 milliseconds maybe. Don't quote me on that, but it's basically they're very, very short. And we've taken this from actual corpus data where these are manually annotated and then the durations have been checked. And then we remove those from our kind of stream of utterances. And so this could remove potentially very short single utterances where you say, okay, or yeah, and then you start speaking. So this was not a back channel, I'm responding and then going into something else. But it does also have a good chance of removing any genuine back channels from the signal as well, where you don't want to have a transition duration where from something to where you're speaking, I just say, because it's just these kind of short things. We're basically just using a rather crude measure to try to get at these just really, really brief utterances.
Thank you very much. Thank you also for the question. Do we have more questions? Maybe also for Wim. You have this session together, so we are, I think, slowly moving to the Q&A coffee break session. So I guess any questions that you might have.
Also, I guess bigger speculative moving forward. I'll just walk away and let him answer, but
So the style of the coffee break. The style of the coffee break.
Turn it on, turn it on.
Thanks. The style of the coffee break and Q&A is to try and just ask questions that maybe relate directly to it, but ideas that you have in mind. Questions like, okay, so I watch football a lot and I see that time taken is different than in design teams. And there are times where maybe the entropy of a football team has a particular characteristic based on they've got a red card or the kind of opponent they're playing. So entropy means something radically different than in the context of Team 10. But there are insights there that you can bring in. So I know that in football, they usually train with less people doing particular things or taking particular turns because they want to master a particular skill. So you have to complete some kinds of passes before you even attempt to make a move and score. So that is the richness I'm trying to bring. So this is the kind of Q&A we want to have. The things you've heard seen in the slides, but much more from what you love, from law, from courts of justice, from studying proverbs, from whatever, cooking, that richness. Another example is when I first met my partner, we had a clash because the turn taking was very strange. In Nigeria, we would talk over each other, and if I have a point to make, you make it, and then I make. But then I saw that in Germany, she was like, "But you didn't allow me to finish." And I was like, "It's not about finishing; it's about really just keeping it going." So this kind of personal insights from schools, from wherever, that is what we think complements the theoretical backgrounds that could shift our mindsets about the things we learn. So that is what this coffee break and Q&A is like. So if you have those kind of questions or insights, you can bring them up just to inspire people. But if not, you could also just quickly have a coffee break or just meditate. The next session will then be Andrea at 14:45. Or should we start earlier? Do you want to? We've told people 14:45, but yeah, if the questions are not going on too long, I don't want anyone to fall asleep, so we could start maybe at 14:30. Yeah, we could start at 14:30 if the questions don't go that long. So we start at 14:30. Sorry for that online. Quick improvisation there. Just so I hope that we also have more detailed questions when Andrea starts to show us a lot of things. So yeah. Then I will do an introduction for Andrea at 14:30. Thank you, William. Thank you, James. Yeah. Cool. Yeah, so it is my very special privilege to introduce Andrea. So Andrea is an assistant professor at the University of Perugia. He was a research fellow and an adjunct professor of engineering economics at the University of Rome, Tor Vergata, and a visiting scholar at the MIT Center for Collective Intelligence. Earlier, he was an account manager at Saatchi & Saatchi since 2019. 2014, Dr. Fronzetti Colladon has been collaborating on several research projects at the MIT CCI. He's member of the ICKN core team and instructor of 4 courses on social network and big data analysis. His research interests include social network analysis, text mining, brand management, organizational communication, and innovation management. For many years, Andrea has been serving on the steering committee of the International Conference on Collaborative Innovation Network, COINS, and of other important academic events. He is the creator of the Semantic brand score and an experienced business advisor and coach. He leads the Business and Collective Intelligence Lab at the University of Perugia. And he looks to unravel the mysteries of human communication and social interaction. He specializes also in brand and business analytics. Andre describes himself as a wild university professor and researcher, but also a business advisor and coach, and he loves photography. So please welcome Andre Fronzetti Colladon and Ludovica from Italy for the session on semantic network analysis.
Thank you. It is all much less than that. Okay, but you are very kind. I didn't know about this, otherwise I would have stopped it. Okay, so I'm here with my friend and our PhD student Ludovica. You are free to come and join me. She told me, Professor, I'm going to faint probably today because it was so exhausting trip, and I said it will be a perfect gesture, right? So it will also be recorded.
Nice to meet you.
Okay, so I'm very happy that you did all the complicated stuff yesterday and this morning, so now you can relax. I will directly start with a story now, and then I will get to that. But it was 2010, and somebody told me this story it's a true story about a blind man. And he's outside a big mall, and he's asking for money. He has a label in his hands, and he says, please help me because I cannot see. So I need some offering to live, to buy food. Then a famous marketing guy walks close to the man, and he searches his pocket, and he says, well, maybe I can give him some change, but I don't have it. Okay, no problem. I go to the mall, I do some shopping, and when I come out, I will give him the change. So he does. He went in the mall, and he stays there about 2 hours. Then he comes back, and he has €2 ready in his pocket to give them to the man. But still, he sees that after 2 hours, the basket of the man was still very empty. So he thinks, well, maybe I can give him €2, but this will not help him for tomorrow. So he sits in front of the man and waits around 20 minutes, and he analyzes the situation. And he sees that it's not a marketing problem because it's not a distribution problem. People were passing by the man and they could see him. He was in a spotlight, so it was not that the message was not reaching the right people. So they were passing by, they weren't reading the label, and they were just ignoring the request. So what he does in the end, he goes back to the mall. He buys a big marker. He comes back to the man, and on the other side of the label, he writes, today is the first day of spring, and I cannot see it, and puts the label back in the hands of the man. And this is a true story, and the basket, you can imagine, gets full pretty fast. So that is the moment where I really thought about the magic of words. And then it happened to me that I said, okay, I can study a little bit, I can read Freud, and I can understand how the language developed and about the magic of words. Because indeed, when the language developed, people could only use little words. I mean, the first words were used to talk to gods or to heal people, so they were used to do magic formulas or something. And Freud tells us, today, words retained most of their magical power. Because by words, you can make somebody blissfully happy, or you can drive him to despair. So still, we want to use this magic. We want to dig into semantic analysis. And today, we will be talking about semantic network analysis. But then I thought, okay, but it's also 10 years that I've been studying social networks. And so I'm studying behavior from another perspective. So why don't we combine the two things and make something out of that? And so, for example, here we were discussing it at lunch. You are looking at a team of physicians and they are performing a liver transplant on newborn kids. So this is the dynamic network behavior within the space of the surgery room. Okay, so there is a bunch of stuff that we can do here, and I'm very happy to be in this bootcamp because you are giving me a bunch of ideas with these networks that I have seen, and with gestures we are doing something. I mean, it's mostly facial emotion recognition with friends from the MIT, and then we are linking that to psychology and so moral values and personality. So there is a lot that we can combine, and there is a lot of that we could talk about. It's mostly about honest signals. I will go back to that. So we call that honest signals of collaboration and human communication. But within this basket, I mean, we have a couple of hours, so I'll try to be practical. I'll tell you something more about an indicator and a platform and an ecosystem of business intelligence analytics that we developed. So I will start talking about this tool and this metric, the semantic brand score. And then hopefully in the other half of my speech, we will teach you how to use the app. So it will not be a 6 hours tutorial, as I originally proposed to Baba. We look at me, and he was right. But hopefully I will give you, I mean, a starting the introduction, and then I will give you access to the app, and then I will give you tutorials and other materials so you can play with that, and you can come back to me for any research idea or ask any information. So the semantic brand score, it's a tool which we use to combine semantic network analysis, so text mining and social network analysis. And it's a tool that we originally designed to measure brand importance. So the value of a brand, the importance of a brand within the speech of people, within the online news, within other texts or corpus that could be interesting for marketing. So it has 3 dimensions. The first one is prevalence, and it's what everybody is measuring in marketing. So sometimes it's called mentions, you know. So if you have a text or a speech or, I don't know, social media posts, you look at how frequently a brand name is mentioned in a discourse. But then we say, okay, counting frequencies, it's not enough. We should consider also other dimensions that make a brand relevant, and we should connect these big data measures through traditional brand equity models. So we look at diversity, which measures the heterogeneity and uniqueness of brand associations. Because take this example, I could have, I don't know, 1,000 tweets that say, I've been at the MIT, it's great. But all the 1,000 tweets are the same. Okay, so prevalence would be high, but diversity of the message and the associations would be low. So then we would have another 600 tweets, and maybe they say, okay, I've been at Northeastern University and I've done this and I've done that and I've met that people. So it's much more rich, the image. So in that sense, prevalence would be a little bit lower, but diversity would be higher. And so we would probably say that the Northeastern brand, in that sense, is more, it's more important. But then we still miss something, that is, if you take a broad discourse, not all associations to the brand, which they make the brand image, right? They are not all the same, because some are more strategic, some are more important, some will bridge connections across the full discourse. And so we need to complete this information with connectivity. So connectivity is the 3rd dimension, that it's a kind of proxy of the brokerage power of the brand. So how much my brand image can bridge across different discourse topics. So the good thing is that this is not only for brands, because this applies to politician names, to political forecasting. This applies to set of words and not single words. So for example, I could define the brand importance of Made in Italy, which is a concept. And as a concept will comprise several other constructs and brands. So I could use the names all together of the Italian companies or the products in the fashion or food sectors, for example. So we can really be flexible, and this is not just for marketing. And I mean, I had an inception 1 year ago when I was meeting with Jonathan the first time, but he gave me this brilliant idea. I didn't do it yet because I really want to do with all of you guys. So gestures can be brands. And so we can kind of inject gestures within the speech and see what is the brand image of gestures and how they relate with the speech. So we put together that thing's beautiful with networks that you were showing this morning with the semantic content. And it's not only a matter of content, it's also a matter of relationships among words, because sometimes you say the same words, but you relate them differently. And so here comes the power of social network analysis. Why do I don't do only a frequency count, but I study them through networks. So that is the idea. And through such kind of tool and metrics, we can get insights from big data. We can measure on a signals, which is, I measure the spontaneous discourse of consumers. I take people and citizenship in their spontaneous behaviors where they don't know of being measured, because it is very much different from the case that I answer to a survey, right? Because I have a lot of biases and I know of being monitored and I want to make the interviewer happy, and there is all this kind of stuff. Whereas if I am, I don't know, if I'm using emails for work, and then I will be more spontaneous. If I post on social media, I will be more spontaneous. Or if my speech is recorded when I don't know it's recorded, we do that in Italy, not abroad, I will be more spontaneous. And this is much better than even doing a fake mall and having people interacting within the fake mall or doing a focus group. I mean, it's more advanced. So and also there are some metrics like, I don't know, if I'm telling you, okay, you are being monitored because privacy law forced me to tell you. So I will tell you, but then I tell you, okay, I'll be monitoring your betweenness centrality. Then it's pretty much difficult for you to hack it, right? So yeah, that is the idea behind honest signals. I'm not yet in jail, but I will be soon. Okay. This can be applied to multiple languages, and again, not only to commercial brands. So it can be Pepsi was Coke, it can be pasta was pizza, because they are two products. It can be testimonials if you want to make an advertising campaign of your brand, or it can be an old brand and a new brand. For example, Telecom Italia, which is the incumbent in telecommunication in Italy, they told me, okay, I want to switch from Telecom Italia to TIM, which is our new brand, it's fresher. And so with these tools, we help them in the rebranding operation. So I hope I convinced you that surveys cannot be the future, but this was clear to many of my colleagues even before I came out with this. And I read on a book of Kevin Roberts, he was saying, really, if you want to do something good in marketing, you need to be an explorer, right? An explorer, he says, without the. And he says, if you want to know how the lion hunts, you wouldn't go to the zoo, you go to the jungle, right? So this is what we are trying to do with the study of honest signals. So my idea now is that I give you some technicalities because I want to show that I can also deal with numbers. And then we give you some case studies, and then we go through the app, which is it is written in Python. So if you are curious about the code, I can share some pieces of code, but it also has a graphical interface. So we will learn how to use that. So again, this is one of the most famous brand equity models. This is from Keller, Brand Knowledge, and he says the equity of a brand comes from its awareness, which is how you spontaneously recognize and recall it, and by the image of that brand. We stick to this model with some proxies. So prevalence will be a proxy for awareness, and diversity and connectivity are connected to the idea of brand image, but the semantic brand score ecosystem is a starting point. It's not exactly this one. And for example, we deliberately exclude favorability of brand associations because we see that sentiment measures are not that much reliable. And more than that, sentiment measures, many times they do not count. So we look at sentiment outside of the brand importance and we combine it in models, and we will show you that it's not always the best indicator. So the process that we will go through is that we need to collect textual data. This could also be the transcript of a speech, or could also be, in the worst case, an open answer to an interview. Okay, so we can still analyze the answers to surveys and interviews through this system. And then we will do some natural language pre-processing. I think you will look at that tomorrow when you see Spacey and some of these operations. So the app does that automatically and does some tasks like dealing with punctuation, removing of special characters, removing stop words, which is words that usually add little meaning to the discourse, like and, the, and so on. It depends. Views are controversial about that. You can look at the work of Ben Bakker. He has a book which is beautiful, The Secret Life of Pronouns. And he says we can do psychological profiling of people just looking at how they use pronouns, and these that for us are stop words. So I'm anticipating the app has other functions, and some of them consider stop words. But for the SBS analysis, we are looking at the semantic network, and these words often appear in all the documents, like they can be tweets or something. So we remove them. And we also perform some stemming, which is the removal of word affixes, or lemmatization is the same, more or less. So if I have the words beauty and beautiful, I will merge them in a single network node because they are kind of representing the same construct. So the main step is when we go from texts to networks. So I'll give you an example here. If we have this sentence, Aurora was bright as the dawn, and yet she was mysterious and dark as the night surrounding the stars. This sentence, you see the red words would be eliminated because they are stop words. And I've chosen a threshold, I don't know, of 5 or 3 words. So already this sentence would produce this network. Then there are a bunch of parameters that you can adjust in the app, so you can define a co-occurrence of 2 words, even if they are just at the distance of 1. So Aurora in that sense would be only linked to the word bright, but we were more inclusive in this example. If you're wondering, Aurora is my mother, so yeah, that might be a problem, but still, okay. So we go from texts to networks, okay? And then we analyze these networks through methods and tools of social network analysis. So how do we measure prevalence? Prevalence, we don't need network analysis. It's very straightforward. We count the frequency of appearance of a brand name. Then, I mean, even in the app, you can normalize these raw scores in multiple ways. Also because when you need to compare different time periods or different networks, you cannot just rely on raw scores. And also prevalence, diversity, and connectivity, they change on different scales. So just because in the end we make a composite indicator, we cannot just sum the raw scores. But here you have the raw scores, then I will show you how we normalize in most cases. So prevalence, it's frequency count. Then we go to diversity. And for diversity, I had to think about a new social network centrality indicator, which we called distinctiveness centrality, because originally this was conceived as degree centrality because it's the richness in the number of associations. You can think about this as a brand node, so it's Pepsi, and these are all the associations in the text. But then I thought, okay, if I have Trump and Biden, then there will be an association that is for sure common to the two brands, that is elections or US. And that association in the news, for example, will be common to many other words in the text. So it's not that much distinctive. People will not choose to vote for Biden or for Trump because they have the association to the elections or to the concept of US, but they will choose to make a vote depending on other parts of the brand image and also on the prevalence, so how much they are exposed to the message. So I designed this distinctiveness centrality metric that for those of you who already know what term frequency inverse document frequency is, or in the question and answers, I can talk more about that. But this is translating term frequency inverse document frequency into a network logic. So I say, for example, if I go here, I say node number 2 has four connections, 1, 2, 3, and 4. Node number 1 also has 4 connections, so their degree would be the same. So they would be regarded as same importance with respect to degree. But node number 1 is the only one connected to nodes 6, 7, and 8. So if we remove him from the network, we will lose a connection with that node. So these associations for node number 1 are very much distinctive, whereas node number 2 is connected to 4, 5, and 3. But these concepts are shared among many other nodes in the network. So this makes these connections less distinctive. So the more unique the brand associations, the higher the diversity. Yeah.
Isn't that always, I thought it was brokerage. Is that a similar concept or no?
Brokerage, it's more because this only looks at direct association. So it goes into it is correlated, of course, with the other centrality metrics. It is correlated also with the construct of structural holes, because if you take brokerage, you can measure it in many ways, right? So it can be between a centrality, it can be structural holes, or it can be other metrics, eigenvector centrality, maybe, I don't know. But still it is different. In fact, we use, and thank you for this, we use the concept of brokerage for connectivity. And we consider weighted between a centrality, because there we want to see how strategic are your associations and how embedded you are in the network. So how much is your ability to bridge across different discourse topics. If you take two telecommunication brands, for example, TIM in Italy and Wind, it's another one. I could have a rich image of Wind about, I don't know, the optic fiber, for example. And so it's highly prevalent and it's high diversity because there is a rich discourse about the optic fiber. But then TIM, it's another brand which has high prevalence, high diversity, but that diversity is made of a discourse about optic fiber, a discourse about the commercial offer, a discourse about smartphones. So their associations are not only rich, but they are also more strategic to the overall discourse. And so this is how we want to measure connectivity, which makes the third dimension. Yeah.
I have a quick question. I was wondering, so it's obviously quite new for me, but say you have like celebrities talking about brands.
Yeah.
Is this covered in your network? Because a celebrity who has like 1 million followers is going to have a wider spread than me when I post about, oh, I love telecom, something, yeah. Right?
Yeah.
So my 10 followers are going to see this, but for somebody who has big outreach, it's going to be more. Of course, it's going to generate more retweets or reposts, but is that enough then from seeing, you know, this is still perception?
Yeah. So we can look at that problem from two perspectives. One is to study the brand and to see within its image how much that celebrity and the values that that celebrity is carrying together appear in the brand image. So that would be an analysis. And the other one is also applies to another reasoning. So I publish an article on a very little local Italian newspaper, and I publish it in the New York Times. So the same message should be weighted differently. And so the app has an option So you can weight the textual documents in order to say you don't have to consider them all equally important. And so if a celebrity is posting, you would attribute a higher weight to that. So this wouldn't change the metric in the end. I mean, these three measures, but it would change the network below. So the arc weights, because the arcs I didn't tell you are weighted by the number of co-occurrences between two words. But if you use a weighted version of the metric, there is a rescaling based on this concept. And so, yes, it's very important. Yeah.
I'm struck by this, what Ola just said and what you're talking about. And after the First World War, I think it was Keynes, was in the photograph of people talking about what's going to happen next. And he's far in the periphery. He's not a celebrity. After the Second World War, he's in the center of the photograph. And what he said was, we can't be punitive like we did. That's only going to cause more destruction. And his centrality, then, it has so much more weight, right? And I'm thinking about who has weight, in a sense, in terms of the persuasiveness or communication power of a brand. Something we used to do in movies all the time is, one of the ways you make a cheap movie is that you feature Perrier or something. They give you cases and cases of Perrier because you show it in your movie. Or this handbag, right? That kind of thing. It's a typical move that you make in order to do this product placement, basically. And of course, the bigger the stars in the movie and the bigger the movie, the more valuable that product placement is, right? And then they play with that elsewhere. So I'm thinking about how this all works in respect to what you said and what you're showing. But even in an ideation, concept generation type situation, who has more centrality because of who they are and so on.
Yeah, that is very interesting to tackle. So again, even here, some ideas, because for example, we have a case study and you could do, for example, if you have an external dependent variable that could be sales or marketing success of some sort, you could calculate the semantic brand score related to one person and to another. So deriving from the speech of that person, or because other people are retweeting or mentioning or connected to that person. And then you measure the semantic brand score on another set of documents related to another person. And then you make a predictive model and you see which was most effective. And we do that, for example, with brand events. When they do a sponsorship or when they do an event, we measure which is the shift in brand importance attributable to that event.
Right.
And the photograph makes me think of another thing that was interesting also in the discourse that we did this morning. When you say synchronicity and we need to be synchronized on some behaviors, but then add complexity on the other side. There is another thing, I didn't want to bother you all, but there is another discourse and we have another metric that we call rotating leadership. So sometimes it's about dancing with the stars, so the best leaders and the people who are mostly influential, usually they do not keep a static position in the network. So maybe they become central in an innovation team, they share a vision, they share an ideas, but then they leave space to the others for interaction. So they go back and forth from the center to the periphery in terms, for example, of between and centrality. And in that case, they can really foster community growth and shape innovation. And we call them rotating leaders, which is the opposite of Italian leaders, that they are pretty static and they keep a chair, they root on the chair.
Is there a relation then between that and their brokerage power?
Yes, exactly. Because when we measure rotating leadership, it's mostly connectivity. And so it's exactly their brokerage power. And so their brokerage power should serve to the activation of important links. But then if you want to do innovation, then you need to leave space to other ideas. This is very different. For example, when I was working for Genpact, which is a global service provider, and we were optimizing communication of teams in order to improve customer satisfaction. In that case, I mean, we have been always looking at rotating leadership as something positive. In that case, we did something that we call virtual mirroring, so a feedback on your virtual behavior, and we told every team, please reduce your rotating leadership, because in a post-sale assistance service, I don't want big visionary leaders that guide my clients. I want some small, reliable people that act as a reference point. And so something not just relating to the semantic brand score, but also when we study other honest signals, something that I always say is that we need to calibrate them depending on the context. And so I cannot tell, if you ask me what is the optimum range of the semantic brand score, I cannot tell you, because it really depends on the context and phenomenon you are studying. Yeah, so thank you. We are making this interactive, and
we have a new construct. I think it's celebrity gestures. So we could explore that.
Yeah. Cool. So, well, mathematically speaking, I'm pretty naive compared to all of you, but here is how we put this together. So I subtract the mean and I divide by the standard deviation, and that is a way. And then we have other, I mean, the software will give you 300 alternatives to this, okay? But this is the most straightforward way to build the composite indicator. So usually now I get a question because they told me, okay, but how do you use that? This is just something theoretical. So I'll give you some examples, and then Ludovica will walk you through some case studies. But this was the rebranding operation of Telecom Italia and team that I was telling you about, and they were getting a feeling that the communication campaign was effective, but they couldn't quantify that effectiveness, you know? And so this is the trend. TIM is the new brand. Telecom was the old brand. They started somewhere here, the rebranding operation, and this is how it went, but we can really quantify the distance. We can also, I mean, when I work with Peter Grohl, for example, he looks at betweenness centrality, and we do social network analytics. But if we look at the text, this is just a couple of days of tweets. It's just an example. But really here, again, we can make a quantitative score to say, okay, brand C, it's obviously the most important, but by how much it is more important. So this is the most straightforward use. So you calculate the score. Then we think, okay, but you need to understand why this is happening, and you need to make a storytelling out of that, either for research or for consulting. So what we do next is we produce another bunch of analytics and reapers that complement this calculation of the semantic brand score. For example, we look at how the total score, I mean, how much each dimension is contributed to the final score, because then you can understand which actions you should take in order to make your brand more important. So if you have a low prevalence, the green one, you should have people talking more about your brand. You should, I mean, through your press office, you should do something, or you should do commercial campaigns and so on. And if your diversity is low, you should enrich the image of your brand. So talk more about different things. But then you have some particular situations. For example, you see Iliad here, it's a brand with the lowest in score, but has a connectivity that it's a little bit higher than the one in the third position, Wind. So improving connectivity, it's about connecting to the strategic concepts. And the app can help you in that, because it will give you some alternatives. And of course, you shouldn't go against your brand values or your company core values, right? But it will tell you if the communication stays as it was in the past, this would have been the concepts that would have made you central to the network. And so we have some hints about that.
I'm sorry, are those correlated, those three measures?
Yes.
Between each other? So say I'm Iliad. Now I want to increase in general. Where would I start? What would be the point? Which of the three ones would I choose to generate the most revenue?
So they are correlated. I ask myself many times, because I'm not a mathematician, does it make sense that they are correlated if I am making a composite indicator? And then in the end, I posted this question on cross-validated and I got an answer. And they told me, yes, it makes sense because they underlie the same theoretical construct. So it's like if you measure degree and betweenness and other measures, they will all be correlated. But well, if your brand is never mentioned, then it will have no importance. So if you are such in a low position with respect to your competitors, I would start by building brand awareness. And this would translate in, as long as you talk about me, that is good. So I would go, I have also a paper that it's named like that for family firm brands in Italy. And so I would increase prevalence overall. And this will bring together some more diversity and some more connectivity. But there are some specific cases. And if two brands are very much alike in the semantic brand score, then you can use a leverage on the other dimensions to improve their importance. So depending on the case, but if this is the situation, you go with prevalence. Yes.
So I wonder, in the case that you have enough connectivity, enough prevalence, and everybody's talking really nice about your product, would you then say, well, increase your diversity and talk some shit about your product? Is that better than diversity?
Yeah, I mean, this very much, again, don't ask me why.
Bad news is good news, right?
Yeah, okay. I will show you, Ludovica will show you my work about political forecasting. And talking about some more shit really works well in Italy, you know, because people will vote you if you have more buzz around your brand. So I was comparing two political candidates to become the mayor of Rome, and so Giachetti and Raggi. And Raggi was really bad in the sentiment, had a much lower image, but still she got almost 70% of votes. And if you were comparing Giachetti's semantic brand score and Raggi's semantic brand score without considering sentiment, they were 30 to 70. So that was impressive, you know. Yeah.
I'm taking more of a design mode here, and I look at your previous slide.
Yeah.
And because our goal is to bridge gestures as brands, teams as brands. This visualization here as a metaphor for, as in, we could put audio there, we could put signals there, we could put affect emotions on that graph and have like a scoring for that. How did you decide that this was the final thing that was going to communicate this very, very well? Because that is also what your session is to inspire us to do.
Okay.
Moving a bit, we know that the code works, it runs, people will learn online, but the visualization and the story of it to inspire how we could do multimodal analysis visualizations in a way that people are at least have it more accessible. So maybe that is just my thinking when you talk about everything. So yeah.
So teach.
So gestures as brands, audios as brands, and they are in that 3D space. And where it's imagining
a teaching style as a brand. I'm thinking about Natasha talking about teaching. Right?
So it is inspiring on those levels, and the more you have to show, don't feel that you have to quickly give a talk, because it's not just the theory that is inspiring, but also the framing of it. And yeah,
this is also one of my reasons for coming here, right? It's not just to give the talk, but also to brainstorm with you guys, because this really intrigues me. I mean, I have an awful to-do list, but at the end of my to-do list, in green, because everything else is in red, but in green, since we met last year, I have this SBS gesture. It's true, I can show you later. And so I can't wait to have this idea of, it's already text mining and social network analysis. And like in the other studies that we make, we add something more. That can be gestures, that can be biometric parameters. We usually do that, but we never did with what you are doing. And so I can wait for that. mean, we can discuss even later. Okay. This is why I asked you 6 hours. Okay. Then you say, okay, but sentiment has a meaning. So what I'm saying is that you can make positioning graphs and you measure brand importance. And then you combine with whatever other metric you might want to consider, okay? So sentiment is an example here. So my question for you is, these are all utility brands. Which one would you choose considering this positioning graph? I mean, if you were to own one of these companies, which one would you go for?
You're Italian.
Yeah.
E&I.
E&I. Yeah, I totally agree, because we see also when we put this in relationship with performance, this is what really matters. And sentiment, well, here you also see in the scale that there is little variation in the sentiment, and it's all positive because it goes from -1 to 1. So it's all positive. But if you go for Ian, this one is so little in the importance that it doesn't matter, because here we could have, like, I don't know, 10 documents speaking very well of Ian. But here you have E&I, you have so much importance that even if the sentiment is a little bit lower, usually it doesn't matter for profits. I mean, it depends on cases, but again, this is an example that tells you you can combine that information with some other metric.
If you were to choose something like Edison, you would really have to have a very good plan to raise your SBS, right? Because it's in some ways, sentiment doesn't matter as much in some ways, right?
Yeah.
Because you can talk shit and you still have a good score. But raising that up is a real trick, right? Like it's like inventing a new brand that everybody likes, but so what?
Yeah.
Right?
Exactly. And then I'm also forced to imagine a team that laughs a lot, and the other dimensions are just really flat. Like Eon type of teams where there's a lot of humor, almost too much. There's a lot of happiness and all that, but the other dimensions are not just catching it until again.
Right. Again, they're all getting along, but they're not doing the hard work of going, wait a minute, what if it's like this, or let's figure this out, that kind of thing.
Yeah,
so cool.
And sometimes you can substitute sentiment with some other measure, and that could make the difference more than sentiment, you know? So it depends on cases.
It's like, again, we could say synchronicity instead of sentiment. That is, everybody's agreeing about everything. It's like, wait a minute, that's flat then, right?
Yeah,
you don't move.
Exactly. So yeah, some difference in that case with that. And then the software gives you some tools to explore the direct associations of the brand. So you can figure out, without reading 50,000 online articles, you can figure out which are the main associations. And you will see that there are some associations that are unique to a brand, so they are not shared with the other brands. So what distinguishes my brand from the others? And what are the main associations are two different questions, and we can ask them. And so with respect to the classical branding models, we also consider uniqueness and relationships among associations, because we also have the link across them. And then we can consider brand image similarity. So this was the primary run for the Democratic Party in 2019, before choosing Biden to run for the presidential elections in the US. And here you could see the 4 main candidates at the time. And so this is a multidimensional scaling. So we compare their brand images along more than 3,000 dimensions, and then we project this in a two-dimensional space. And we can see that, for example, Sanders and Warren are very close to one another, so they don't differentiate their communication so much. Or when journalists and other people talk about them, they project the same image. whereas Buttigieg and Biden have a different positioning. And that was something good for Biden. In the end, we will also see it through some topic modeling, but Buttigieg, because he was the first gay candidate in that scenario, and so the image was different, but that wasn't enough because the semantic brand score was low, whereas Biden was very much related to Trump and so to the Ukraine impeachment in this example, so it has more concrete stories around it. Then we can also define our own dimensions. So the app will give you the possibility to say, hey, but I want to understand how much my brand is about sustainability, how much my brand image is about technology. So we give you, we give you like 100 dictionaries to explore. They are pre-made to explore the brand image. And they are also inspired from other software. So there we are not reinventing the wheel, we are just complementing our analysis, and we are looking, for example, at LIWC, which is a software from Pembacher. But here you can also define your own dictionary that has all the words related to sustainability, and you can get a metric about how much that image is about sustainability. Yeah.
So what I'm thinking about, we have different kinds of gestures, right? You had a slide which listed all these different kinds of gestures. That could be, for example, technology could be metaphoric gestures, right? This could be so-and-so gestures, that kind of thing. Iconic gestures, it's a dietic, I think it is, right, gestures. Right, and that's one way of looking at this in terms of gesture profile dimensions, as it were, right? Looking at that.
Yeah, I'm curious. For example, you could have some gestures that relate to the concept of performance, some gestures that you make when you want to express a new idea. And so it's all, it's very interesting to explore. Then we give you, we have other basic functions. Yeah.
I'm sorry, but I'm just thinking, because we looked at media, we looked at gesture, we looked at language, we could have scores for each of those also, and to see what characterizes a team between those. So those would be dimensions.
Yeah, that could be definitely. So we could also have dictionaries. So you could calculate the semantic brand score on the concept of performance and on the concept of idea generation. And so the brands would be these constructs. And so we would have a set of words to define each of these constructs. And then we could combine with other predictors that you might want to generate, that are the gestures and all these. So yeah, and really we can look at team performance 360 degrees. So that would be great. So then the app can extract keywords without, even before running the semantic brand score. So it has some basic functionalities of natural language processing, keyword extraction. It has a topic modeling algorithm, because when we were looking at associations before, that were only the direct associations, but I could be indirectly associated to a concept. And so we use a network model to extract the main discourse topics, and then we relate these topics to the brands. And so here you can see, for example, Buttigieg, Warren, and Sanders are all in topic number 4, primarily because they are associated also with the other topics. But this is their main topic, which is pretty boring. It's presidential campaign, primary, debate, Democrats. It's all about, we will be having the elections, okay? Whereas Biden, it's connected to Trump, to Ukraine, to the impeachment, to something that it's really happening in that week of the analysis. And this was a premium for him, because even when we look at the time of the discourse, because Ludovica will show you, but the discourse around Biden has many more words about the past, what happened in the past. So it's something that he did and is reported in the news. Whereas when we talk about the other candidates, it's more about the present and the future. So they went to this event to do their political campaign and they promised to do that. but people appreciated more the fact that they knew somebody who was doing something for real, and so they could judge him about what he was doing.
So you use Luke for that particular to operationalize past, present,
Yeah,
future?
so we took, I mean, just because we use this only for research, that part, and we don't sell it, Luke dictionaries are public, and so we kind of got an inspiration from that. We changed them a little bit, and we use them in the software, so it gives you something very similar to their results.
I was asking, so I was also then wondering if that is another level or layer to making sense of gestures in terms of you talk in present tense or past tense or future tense.
Yeah.
But the co-occurring gestures when people are talking more about past tense, yeah, maybe that's another level to also zoom in on. Yeah.
There is only one problem if you just use that approach, is that there we only count frequencies, whereas the words related to the past, present, and future, or the words related to anxiety or to risk-taking or to cognitive processes could be better analyzed. So you could also take the dictionaries of Luke and calculate not only their frequency, that there is a part in the app, but you can calculate their semantic brand score. And so you use them as a construct. Okay, that could be an alternative as well. We are talking about advanced uses, you know. Okay, so for each branch you get the strength of linkage to a specific topic. So you can see Biden is mostly in topic number 1, whereas the other candidates are in topic number 4, but still there is a percentage of the discourse of the other topics that connects to them. So this is another possibility. And then we have, well, the relevance of each topic, and this is a matrix, so the darker the square, the more connected two topics are. Well, and then we complement all these reports that would come in the main graphics of the app with some tools on the side. So we have other textual statistics, like we calculate language sentiment, complexity, sort of emotionality, and other statistics, and the informativeness of the language. And we do natural language processing. So all this kind of stuff that, I mean, I put them in a single slide because they are not so new. And then there is a new menu since a few months in the app that will allow you to do social network analysis, but our is not a social network analysis software. So I'm implementing there just some functions that I do not always find in other software. So we can calculate betweenness, closeness, degree, this kind of stuff, but our software also calculates distinctiveness, which is a metric that you don't find very often. Now it's in some packages, but not in everyone. And you can calculate rotating leadership. So it's kind of, or you can calculate similarity among networks. So you can get a matrix which will tell you how much each network is similar to another. And each network could be a week of the discourse. So you can see how the discourse was similar to other weeks across time, or each network could be one person. And so you can see how the speech of one person or a candidate, for example, relates to the speech of another one. So how their semantic network is similar, it's comparable. Okay, so before going to the app, we have, I mean, we will take 10 minutes, I guess, to go quickly through some case studies that will show you some applications. We just put some of them, but then if you go on semanticbrandscore.com, you will have more papers. And then I want to walk you through the app just a little bit to give you an idea. So I think we can do this together.
Okay.
So I leave you the floor.
Should we take a short break? Or
Sure.
Or
Yeah.
Yeah.
Okay.
So you can.
You tell me the schedule.
Technical.
Okay.
Setup, and then we have a 5-minute break. Just pee, stretch.
Yeah.
So there's a case when we all clap of really reduced complexity in gesture. Right? If we're all clapping at the same time, it's the same thing, and it's a conclusion of something.
Yeah.
Right?
Yeah.
Well, guess we all agree.
Yeah, it's true.
And there's no rotating leadership at that moment at all.
So for everyone online, we're taking a 5-minute break and then we'll be back with case studies.
Can I use it?
Yes.
Okay.
Are we unmuted?
No, you're unmuted.
Okay.
It's okay?
Yeah.
Okay, perfect. So let's start with a case study. And the first group of case study, it's about a use of the SBS to forecast outcome of political election. And during the presentation, I will show you how we apply the SBS, but if you want more information, we can find the, you can find the reference on the slide of the papers. So the first case study, it's about 4 Italian events that are the Italian constitutional referendum, Italian general election, Rome municipal election, the first and the second round. The goal is to know if the SBS perform, how the SBS perform with a different voting rules. So we calculate the SBS for different words because the voting rules change. So, for example, for Italian constitutional, we calculate the SBS for the word yes and for the word no, while in the second event, we calculate the SBS for unnamed party leaders and so on. So, in this case study, we collected news with a Python script that interact with the event registry API, and we collected news 2 months before the election. The first voting event is the Italian constitutional referendum that was promoted by Matteo Renzi, that is the gentleman on the slide. And the first step is to calculate the SBS for the word yes and for the word no, because voters have to express their preference if they want to reject or not reject a law. So the first step is calculate the SBS for the word yes, and then we apply this formula to predict which is the number of people that decide yes. So at the end, we know that only 14.9% of people express their preference for the word yes, and using this formula, we know that the SBS forecasts very well this result because we have only an absolute error of 1.16, so it's a good indicator for our objective, and it's very and it is it's performed better during the last week, the 1 week before the election, and compare it with the traditional methodology, so the polls, it's better than the polls. So another event is the Italian general election. In this case, we calculate, yeah.
So in this case, is a poll the same as a survey?
Yeah.
Yeah.
But there is a poll ban in the 2 weeks before the election. And so we claim we can use this because it's more accurate, because what we are proving in this study is that citizens are very much influenced by the media. Yes. in their voting.
And the polls are an important part of that. Polls are
Yes, yeah. Exactly. But in the analysis, I mean, when you look at that error, you don't have the poll results in the news because it's in the 2 weeks before the election, and in Italy we have a poll ban. And so here you have an absolute error, but in the next slide you have a mean average percentage error. So you see.
Would it be fair to characterize part of your work, your brand is to kill surveys? I'm all for that. I hate surveys.
Yeah. I'm trying to do that with the institute in Italy that use surveys the most, which is the National Institute of Statistics. And they, for example, they measure the CCI, which is Consumer Confidence Index, so the confidence that consumers have about the future state of the economy. And I said, okay, I can calculate the SBS on news, considering some words that would affect people's perception about the economy, the Italian. So, for example, economy, European Union, and spread, and so on. And And I find out that it pretty much resembles the results of the survey. So I told them, okay, then you can save money and can use our metric and drop the surveys. But still, you know, they are reluctant so far. I mean, I think we can go fast on this, but the idea is that we can make political forecasting, and our results are usually better than polls. And even when you see big error numbers, it's because this has become a mean average percentage error. So it's not an absolute error. If I say 2% and it's 1%, my error would be 100%. So that it's not so big.
Okay. And we know that the SBS perform better if you have a fewer candidates, for example. And okay. So in addition, we use the SBS for other political events, for example, the Democrats primaries, but I can skip it because we talk about it.
Yeah, that was just to show you that we can make word clouds.
Yeah. Okay. So this is an extra function of the SBS BI app, and in this word cloud we can visualize which are the most important topic in my news, in my articles, without read all the news. So, for example, we know that the main topic are about Trump, impeachment, Ukraine, Biden, and so on. And this is a topic modeling. So
we
can I
went
skip?
through that.
Okay, this is the discourse about the dimension. So we know that all the tweets of the online news about Biden are focused on the past, on the present, and are not focused on the future. So if we want to create a new communication strategy, we have to introduce this dimension. For example, we know that the tweets, the articles about Biden are more simple, than the other candidates. So maybe use a simple language. It's useful to allow most people, most citizens. And the complexity and formativeness are two dimensions in the extra function to explore the image of our brand.
Being less informative, it's good because it means that there are more articles and that the message becomes more redundant. But this is good for the awareness and the image formation in the minds of citizens, right? And then people, just because you consider the average voters, not everybody has a PhD, and so they would appreciate a simpler message around a candidate, around a topic. And sometimes also with a PhD, we appreciate that.
Did you run those with, say, in the Obama election to see did Obama have the ability to simplify like that, or be perceived to simplify?
No, I didn't do that in terms of complexity, but if we consider, because I love a thread of studies about the pragmatic of human communication, which comes from the Mental Research Institute, so I'm referring to Paul Václavic and these kind of people. And so we applied part of their brief strategic therapy. So we took down the message of Obama to emotions and compared it to that of other political candidates. And so basic emotions in our scenario were fear, joy, well, I would say pleasure. Then we had fear, joy, and I can't remember the other two. Do you remember the basic four, the one that we covered? No. Well, Obama, it's shaping a discourse around pleasure. So yes, we can. Mm-hmm. That is the power. And so if we measure the SBS of pleasure, it's very high in his discourse. Whereas other politicians like Draghi, like Monti that we had in Italy, is if you do not vote for me, then things are going to be bad and we are going bankruptcy and we will have some problems in Italy and everybody will lose a job. So there we measure the SBS of fear. That is another basic emotion. Now I have a blank on the other two, but so these were the two relevant.
So these must be relative. That is, what would work against a Biden or a Trump may not work with Amante or someone else, right? Because that whole discourse is a relative discourse. It's not that simplification is, well, it may be simplification is always the best, but
yeah,
it may not be. It may be at a certain point, a little more complexity might be a good thing, depending on the context. Yeah.
Yes, it always depends on the context. And by the way, the two other emotions that you can leverage are pain and rage. So some people like Grillo, you should vote me because you are angry with the other parties, you know. So that is also another strategy. And pain, they don't make a leverage out of that. It's like if you have a personal loss, but sometimes they do. For example, after an earthquake, they use that pain to get votes, which is not so ethical, but okay.
Okay, this is a case study about the use of the SBS for the Turing forecasting, and in this case study, the authors analyzed 10 years of online forum news about 5 European museums. And we note that there is a positive correlation between the SBS and the number of museum visitors. So in this case, we introduce external variables and we forecast it with the SBS. And
sorry, if you can go back, as you see from the slides, the positivity or negativity of the language. So I'm making a review about a museum on TripAdvisor forum. And I discovered that it doesn't matter if they say that this museum is good or bad. People will go there just if the SBS is higher. So regardless of the sentiment, which is a variable that we put in the regression and it's not significant. As in these other slides, the next one, you see that SBS is connected to firm revenue. In the case of family firm brands, this is pretty common in Italy, so we have many family firms. And there is a moderation effect of family firm identity. So when the image, the brand of the family overlaps with that of the company. But again, it's not shown here, but I wanted to say the sentiment is not relevant even in these models. So I'm not saying that sentiment is never relevant. I would never say that. But I say that in many business cases, it's, yeah. It's something.
But could it be that people are also sometimes complaining that something is too crowded, which also indicates popularity? Like in general, when something is very popular, that also increases the negativity of certain aspects.
Yeah,
Can that happen?
But then there is a social effect that if it's crowded like a restaurant, then you want to go there, you know.
Yeah,
so
yeah.
it's one of the laws of persuasion. When it's scarcity and this one, yeah.
Black Friday.
Okay, this is a case study where we apply the SBS not only for a word but for a cluster. So we use the SBS to calculate a set of words that represent a core value orientation for our firms. So we are interested in understand which are the most important interests for my stakeholders. So we analyze 5 stakeholders: association, communication teams, customers, employees, and media. And we analyze the SBS for this cluster, the 6th cluster on the x-axis. And we know a particular things that stakeholders are more interested in a customer, in employees, and not in social responsibility. And this is a particular result.
Yes, for customers, we also mean all that is related to customers. So the products features, and employees is about, because this is a study on company core values. So for example, this is for the Fortune's top companies, right? But a friend came to me and he told me, I'm setting up a new company to sell t-shirts, and which should be my core values. I should focus my communication on the fact that I'm socially responsible. And can we stop the recording? People don't give a damn. Okay, so in the sense that, I mean, they care about, but it's not, I mean, in our opinion, the the prevailing interest of stakeholders. So they first look at how you deal with your employees. They first look at how you design and the characteristics of your products. Then social responsibility can be a plus, but we surprisingly find that this huge interest that it's narrated around social responsibility is less than expected. And also, people talk about CSR, corporate social responsibility. We split it because we say one thing is that you don't pollute the sea, okay? That is citizenship, you abide the law. And the other thing is that you go cleaning the sea that has been polluted by somebody else. That is social responsibility, but for many people, that should be a duty of the government, of Greenpeace or other associations should not be asked to a commercial company like Microsoft. So it can be a plus in communication, but we don't find so far, I could be wrong, that this is a tipping point in the revenues or in sales. Yeah.
So what function does it serve? Are they just wrong to do it? I don't mean wrong to be socially responsible, but in terms of branding, does that mean it just it doesn't seem to have a big impact? And it's just kind of like putting icing on a cake.
Yeah, you know, it's good for the brand image because you build positive association. So again, it's sentiment of that image will be higher, but then, I mean, sometimes it's different if you have a scandal, like you are ENI and you have a oil platform in the sea and that gets broken, and so you have a problem and you want to reduce the SBS in that case. But in this scenario, we didn't take a time frame with such events. So on the regular operating timeframes of companies, we see that the impact is lower.
So if we're looking, it's interesting. I was thinking about an oil company just before you were doing that. And so basically, people usually don't stop buying gas because an oil company has a spill or something, right? Or even if they drag their feet in cleaning it up. I'm wondering about, on the other hand, a company like Patagonia, which is banking so much of its conversation and communication on, we are turning our company into total sustainability. We use this and this, we do these things. Maybe because their customer base is a little bit different. You know, it's like more towards, I love the outdoors, this and that, and this is, and I want it, and it's a luxury item also.
Yeah,
right.
In fact, this is done for a very general customer base. It's not targeted. So there will be market segments for which being socially responsible, it's much more effective, right? For example, I love Patagonia and I wanted to buy a jacket the other day, but it was too expensive for my Italian salary. You know, so, but what I'm saying is that another thing is that some brands are becoming commodities, right? So it's very difficult to differentiate their products. If you think about sneakers, for example, they don't have a big difference in performance. So in that scenario, it can be that if you are on the same level of performance and on the same level of taste in terms of design, then being socially responsible could be the differentiation that helps you succeed in the market. But on the other hand, when it's very general and it's, well, this is 50 companies operating in different sectors. So yeah, this study has, I mean, it's interesting on a part, it has limitation on the other part. So we want to be a little bit provocative here and start a debate, you know. Yeah.
Okay, we can use the SBS to evaluate sponsor and events. If I want to decide which is the celebrity, which is the influencer that represent better my brand, so I can use the SBS for this case study.
So you look, if I pay Bella did so much to do the Bulgari communication campaign, is it worth it? You measure the SBS. Does she carry the values that my brand is carrying? You look at associations and you see if there is an alignment or not. So you could do the similarity plot of testimonials and see which one is more aligned with your brand values. That could be another option. Yeah.
or we can use the SBS to evaluate which is the best product. So if I want to invest my money and if I want to open a new Italian restaurant abroad, I want to know if I have to sell pizza, pasta or ice cream. And I can use the SBS to understand which is the important for the market to minimize my risk. So.
Sorry, what would be the difference of ice cream? Like I can open an ice cream place, but if I open in Germany a gelato.
Yeah, gelato.
Oh, this is a different story. What is the difference of a name, of the characteristic, maybe even symbolic characteristics of my sounds that I use in a name? Can I evaluate this with the SPS, or
yes,
have you tried doing like with sound symbolic names?
Yeah, because the gelato already brings Italy within it, you know, and so you can use the SBS. Probably ice cream is more common, and so if you look at news, it would have higher SBS, but a market segment would be more affected by the word gelato, because if you look at the image, they would be pretty much different. Yeah.
Okay.
Okay, so tell me how good are we with the schedule, because if I have...
Huh? Good 45 minutes, no?
Yeah. We would start the...
You're making us talk a lot. It's so, like it's success.
Yeah, so we talk less, it's better for us.
Okay, but we started a bit earlier, so we have like 30 more minutes.
Yeah, I don't want to bother you too much, and I will keep some time for more questions.
There's no bother. I conceived of the later part of your session as maybe you have more slides that can inspire us to imagine what the original toolbox visualization could look like. Digging deep into how you evolved the product, the brand of the SBS, to learn from you from that, and just some more general questions from the audience. Yeah. So this is what I imagined, but maybe it also looks very, very top down, and I could also just take them back. It's really like free flow from here on.
Okay, so I will take like 20-30 minutes maximum, so we finish earlier, to show you the app a little bit.
Yeah.
Because if some of you wants to try or wants to test it and give me ideas, that I want you to enable you. So I'm doing 3 things in terms of the app. So first of all, you can see my screen.
First of all, thank you, Ludovica, for
thank you.
So I told her like 1 week ago that she was coming, then she started a PhD 1 month ago. So yeah, but she's a good one. So I try to see if they survive, you know, and she's doing that great. Yeah, so a few things. I sent you a link that you are free to share with the participants at the end of the bootcamp. It's very boring because it's like 5 hours tutorial, but it will guide you through every single functionality of the app apart from the network menu. So just for those of you who are very curious, and it's not enough what I'm showing you today, you can go and look only at some parts of the video. That I already shared with Baba some free access tokens, right? So some usernames that you can share among participants with a password, and this will stay open like a few months. But then if you want to use the app for research, I mean, if you use it for business, not even ourselves, we use it for business really. So that it's not okay. But if you want to use it for research or for study or whatever, you can also write me an email and I will create a personal account, or if we want to partner in research, we are very open to that. Some more information like the latest papers and this kind of stuff that regards the SBS with more applications you can find on semanticbrandscore.com. So here you have some information, a demo, which we will see right now, and a link to the web app. So the web app is on a shared server, so if you need more computational complexity, we can discuss that because it's web-based. But the main website where you would log in, it's bi.semanticbrandscore.com. So now I will quickly go through. It can be boring, so I
Is
will.
there an Andrea FC1?
Yeah, because that is for research. 2 is for teaching. Yeah. So
Your father got it right.
yeah. So, well, the basics of the app is that here there is some documentation, but the basic functioning, the idea is that you use the app for fetching, but it's not very much evolved in that sense because we are focused on the analytics part. So you can fetch data. I mean, if you go in the app, you can fetch from Twitter and event registry, but you need to pay to use event registry, whereas Twitter, you can use it also with the premium API if you are an academic for free. But then, I mean, the home page is this one. So give me a text file. This is the idea, because if you can make transcripts, I mean, and it's not so much complicated. So the structure of the text file that we are expecting, it's like this one. So it's only a CSV file. You can look at the first row. It has text in the first column. Then you have a CSV separator, which in this case is a comma. And then you have a date. And the date has to be 2 numbers for the month, 2 numbers for the day, and then 4 numbers for the year. If you do not respect these rules, it's gonna break the program, and so you won't get the results. But otherwise, and of course, if you use the comma as a separator, the comma shouldn't be in the text. Okay, these are simple rules, but you just need, you can put an additional column in this file. So you put another comma and a number, and that number would represent the weight of the source. So the discourse we were making before, if weights are not all the same, like in this case, they are tweets, we consider all the same because we also consider retweets. So we take into account that paths. But for example, you can weight this tweet with the number of followers that person have. And so that could be the third column, right? So if you upload your own textual data, we only ask you to respect these few rules. And the encoding has to be in UTF-8. Okay, so I'm using Notepad++ here because it's an improved text editor and it's very convenient for working on text. So you take the file and, well, I will skip some steps here, but you drag and drop it and it will upload on the software. Then what I suggest is you validate the file to see if you make any errors. So here you will specify the CSV separator. It was the comma in my example. And sometimes you want a minimum length for a textual document. So if the textual document doesn't have at least 3 characters, that is THX, that stands for thanks, I would exclude it, okay? So here the minimum is 3. You can choose to validate the third column in case you have it in the text, in the file or not. And you can also choose to use this function to remove, sometimes you have a line with a strange characters that didn't get properly encoded, so you can choose to remove lines with errors, or you can say, okay, I downloaded all the tweets about, I don't know, TIM, which is the telecommunication brand in Italy, and I took a lot of tweets about Tim Burton, the director, and Tim Cook from Apple, right? So I will put here Cook and Burton as prohibited words, like this.
But what if cook is to cook? Somebody
Yeah.
is cooking. I'm cooking and calling my mom with new team network.
Exactly. So that would be an issue, and that I would tackle even better when I download data. So I would structure a proper search query on Twitter that will only take, I don't know, for example, I did an analysis for the Lenovo brand, but they asked me to do this analysis for the PC market. And so I needed to exclude all that was related to smartphones, even when I was looking at the competitors like Samsung or Apple. And so I was looking at Lenovo and PC and some other specific words related to the PC, right? So this is a possibility you have now. The first step would be to validate the file and see if there are errors. So you click on validate, then either you refresh the page or you click on the check status button that refreshes the page. And you can download the clean input if you removed something, otherwise would be the same file that you uploaded. And here you get a message, no errors found, and it tells you the time period and the number of lines. So you can double check. Now I have uploaded a file about fashion brands. So I'm studying the communication of Gucci, Fendi, and Prada as fashion brands, and I will give you that example. So after validation, here comes the boring part that you also have. How can I, because you don't see. Sorry, let's see if I can. No. I can switch across tabs because I have something in my, okay. So if you forget about parameters, you can go in the documentation and you will have a description of all the possible settings that you can specify in the app. But in general, there are some basic settings. Sorry, this. Okay, there are some basic settings. These are very trivial, so you need to specify the name of the file, the CSV separator, and the time unit of the analysis, because I could have 1 year of tweets and get the SBS time series every week or every day or every month, right? So here you choose to have it every day, it's days 1, otherwise it would be days 7 and so on. And if you have a data set from March 5 to March 12, you could also choose to analyze in between March 6 and March 11th, okay? And so you choose the start time and end time. And here you list your brands. So Fendi, Gucci, and Prada. Pay attention that is in this field, you only have to put a single word. So if you have a more complex idea, more complex construct, you need to use another field below. But here you need to identify that construct with a single word. It can also be a code. F123, okay, that could be a brand. Then a language, and this field I would keep it low, but around 2 or 3 is usually good. It says, please remove all the links from the co-occurrence network that at least don't have the weight of 2. So if a co-occurrence is happening only once, it's probably driven by chance. And so we would remove it. 3, it's a good number, but if you put 20 there, you will keep only very few links in the network. So, and in one day, you will probably have an empty network because you wouldn't have 20 co-occurrences in one day. And then here you can choose to generate topic models. So in terms of languages, we have 5 here because for these 5 languages, we have stemming, sentiment, and stop words already implemented. Because sentiment, we only have for these 5, but you can use like 20 or more other languages if you want to skip sentiment and work only on stop words and stemming or lemmatization. So these are the basic parameters. You will click on save, and if you don't get an error here, it's saved. Then there are some advanced settings, like I want to remove stop words also in Danish. I can select it here, or I can skip the removal of stop words because I already uploaded a textual file that has been pre-processed. So tomorrow you learn about Spacie. If you pre-process your documents with Spacie, then you can say, hey, I don't bother of cleaning again through the SBS, so I can skip it. And even here for stemming or lemmatization, you could skip it or choose another language. So you see many parameters, but they are not really what you guys do. It's more complicated, I guess. Okay. Then you can define custom stop words. For example, in tweets, we have the RT word that stands for retweet. So we want usually to remove it. And this is an important field because this is about, I could have some brands that are more complicated. So Prada can also be @Prada because it's Twitter account, or it can be Fondazione Prada, which is the philanthropy side of Prada, or Fondazione Prada altogether. So here you can define whatever clusters you want, and you can also put, for example, if I want to include beauty in this cluster, I could write beaut and put an asterisk in the end, and this will take beauty, beautiful, and all the declinations, right? I will remove it because it's out of topic. And then what else? So in the news, something we forget to tell you is that when we did the political forecasting, we only look at 30% of the initial text of the news, so the title and the lead. We excluded all the remaining articles because that were online articles and people usually only read 30% of web pages, right? So we did the analysis with 100% of text and only 30%, and results were pretty much the same. And well, 30% was a little bit more accurate. So this is something you can do here. If you lower the number of 1, you can put 0.3 and you will get only the 30% of the document, the initial 30% analyzed. And then the work occurrence range is typically from 5 to 7 in my experience, but the system is pretty robust to this choice. So if you put a higher number, it's not going to change the results that much. Well, if you put 1 or if you put 20, they are going to change. But from 5 to 15, it's usually almost the same. So we keep it at 5 usually. And then you can play with the metrics, like you can play with internal parameters of between centrality, you can distinctiveness, or you can play with parameters in the topic modeling, but this is going to be out of, I mean, if you are curious, I can go through that, but it's more advanced settings. So once you are happy with that, you can also put a name here and save the parameters configuration for a later use. So you would find it here, fashion, and I can import it. Once you have the parameters, the big part is done because you go on the analysis and here you run the analysis. This would take around 15 minutes, so I'm not running it right now. We will work on improving the speed and the computational resources of the server, but it's very low at the moment because it's free for me, and so it's okay. And here I can save my, once I have done the run, you will get these buttons here, and you will have the results that we will show you in a second. You could see the report, which is a graphical representation of the results, but on the side you have all the Excel files with a bunch of metrics for doing statistical modeling, so you can download the results. You can save the report, and you can also download the networks or the textual files that have been organized into time units, so in days and clean. So you would get something like this. So you would get the results. It's a bunch of files, like the associations, the SBS file. So you see that for each brand, in each time frame, you get sentiment, you get prevalence, row coefficient and standardized, diversity, row coefficient and standardized. This is standardized between, I mean, it's normalized between 0 and 1. And so the sum can go up to 3, okay? Then if you, I mean, if you want to be very much complicated, here are the 340 columns and so on of variations I was talking about. But this we can use in research because sometimes you do interquartile standardization instead of regular standardization, and this is more informative for a deep learning model. I don't know, but okay. And then the networks in PyEC format. So if you want to, even just to use this tool to generate semantic networks and play with them, you can do that. And this will give you a report of results that we will illustrate in the last 5 minutes. I want to quickly go through the other functions. So here you can use this function to extract keywords. And once you take the keywords, you can make, for example, a word cloud, okay, in the shape you like. So sometimes you do this before running the SBS analysis to see what are these documents about. Is there something that I'm forgetting to put in my clusters and that I want to analyze? So this is a preliminary analysis. And then I have some people who use the app for doing natural language processing. So they use it just to clean their text. So this is a corpus cleaner. And then we have other functions that will carry out that image analysis that we were talking about. So they will calculate all the dimensions of Ben-Baker and other dimensions like the complexity of the associations, the anxiety, cognitive processes, present, past, and future. So with these functions, you would produce such a file. Let me see. Such a file where you have a bunch of columns. Some represent the complexity of the language, some positive emotions, negative emotions, and you have several scores for each dimensions. I'm not being specific through that because I want to show you the main reports, but you have all this information here. And Image Explorer and text analysis are exactly the same. But text analysis, it's done per document. So regardless of the brands, you do this analysis, anxiety in each tweet. Whereas Image Explorer is anxiety in each brand. And so you analyze the brand image, but the columns are pretty much the same. And then we included a networks menu where you can calculate betweenness, closeness, you can do community detection, distinctiveness, centrality, and rotating leadership and network similarity, the functions that I were describing before. But this is all extra functions, right? The main analysis is calculating the SBS and making sense of it. And so this is the results file that I was showing you before. And this report, this set of graphs here. So the first one is going through SBS time trends. So here you have different brands, and you can see from this analysis that Gucci is the strongest one in terms of SBS, and you can see how this evolved over time. These are interactive graphs, so if you want to remove Gucci, you just click it and you play and zoom it with the software. If we were doing a political analysis, I wouldn't be so much interested in the standardized scores, but in the proportional values of the SBS of candidates. So you can get them here, and so you get a percentage. So as a proportional strength, Gucci in March 11th has 79.4 proportional strength. So these are the time series. Then we have the brand positioning, which is how SBS compares to sentiment and how this can change over time. So you can get dynamic graphs that see if things changed, particularly on a given day. Even here, you can remove a brand, for example. You have this one. I have already gone through that, but you can see rescaled from 0 and 300, you can see how much it's in each dimension is contributing to the SBS in different ways. And well, I would give you the floor again about that because we can comment a little bit more on the topics and associations in this case study that you carried out. So here we have the top associations. So for example, you want to see, and Ludovica will tell you why. For example, here we have Gucci, which is the top brand, but why this is happening? She will go through the associations a little bit. Here, if you want to see the top associations, you click on Fendi, and you can see which are the words mostly occurring with Fendi. And if you go on the unique tab, you see which words distinguish Fendi from the other brands. Or you can also disregard brands and say, I want to see what happened overall on March 11. And so you explode a specific day and you get information about the most frequent words in that day. It's all things together with the topic modeling that it's below that will guide you through the content. Then you will probably have to read a couple of news to know what this is about or to read some tweets, but not so much. I mean, we want to save you the work of going through the documents. Yeah.
So in terms of the time things, the Envision time set is at tops 30 minutes. Sometimes in one case 22 minutes. if we were to bring this in, the data in, would the time, could we scrub through the time to see what's happening at any
Yeah,
moment?
yeah,
like
it's
that?
not a problem. So if you have different groups and you want to compare the groups, what you do if you pick a fake date, identifying each group. Or if you have like 30 minutes, but this is not designed to go through minutes, we can divide them in blocks of minutes or like 5 minutes or 1 minute and put a fake date for every minute. So we make a dictionary of date with the right time or with the right group and we run the program. What else? Here we have the image similarity and the topic modeling, and that's it. But so we could give them in the last 5 minutes some context about why Gucci is winning, and so we can really get a feeling what is the winning strategy of Gucci and why this is coming to the top, and what I could do to improve my positioning or my strength if I am another brand, right?
So we can use this graph to understand that Gucci, for example, if we use the unique association, we can understand why Gucci is so important during this time interval. So unique association, I click on Gucci, so the graph opens, and I know that Gucci is connected with words like Kai for Gucci lunch. So we understand that during this week, Gucci decided to launch a new collection, and it decided to use Kai, that is a Korean singer of a group that is the EXO, to launch this new collection. And this is why, and using this graph, we know that these words are a unique association for Gucci. While, for example, if I click on Prada, I know that the most association with this brand are American's Cup, because, for example, Prada is a sponsor of this event, or Miuccia, that is the stylist of Prada, while, for example, Fendi, that is the Fendi, that is the purple line, and this brand is not very important during this week, and we understand that the problem is that Fendi doesn't have a distinctive image, because it's compared with a lot of competitors, like, for example, Celine, Ford, and so on. So we can use this graph to understand what happened during the analyzed period. And
it's commercial tweets.
Yeah.
So they say, I'm selling Fendi, Prada, and Gucci, and Celine bags. So connect to my website.
Yeah, exactly. And we can use a topic modeling to understand this. And for example, in this graph, the box plot, we have a topic, and we know we can zoom it, or it's simpler. We can show all the words that are included, involved in a topic. And we know that Gucci, Gucci, it's involved in the topic 1 and in the topic 2. So I can scrolling up, and I know that the topic 1 it's about Kai, and the topic 2 it's about Gaga, Lady, Adam Driver, House. So we understand that during this week was filming the film House of Gucci. So this is a perfect strategy for Gucci to increase its the importance of its brand, for example. While we know that for Prada is associated mostly with the topic 7, and we know that we find words like American's Cup, match, fashion, so fashion events like the Fashion Week, and so in this topic model, we can find our brand in red, for example, brand Fendi, and we can move, we can adjust if we want to use, for example, this image in our paper, and we understand that Fendi in this case is most associated with other brands like Tom Ford and Louis Vuitton and so on. And at the end, we have two graphs about the importance of the topic. And if you want to discover, to understand which are the most important topic, we use this graph that is a ranking of the importance. And this is a heat map that shows how strong are the connection between two topics. And
And that's it, I guess. And yes, these are the words suggested to improve connectivity. And in the below the topic modeling, you can see that we developed our own approach to topic modeling. So we don't use LDA, and this is pretty effective. But I think we simplify the approach and we get good results. And for every topic, you have a list of words. So sometimes if you run the analysis, you will tell me there are some topics that are out of scope. You disregard them because it's sometimes you have Italian tweets and just a subset of dirt where tweets are talking in English. So it will put them in a single topic with a low importance score. And if you can show the list of words below the network graph, yeah, here you have, for a given topic, maybe you could have listed a word that makes little sense in that topic, but you also have a score. So you should consider as more descriptive of the topic, the first word with the highest score. I think also for your happiness in the evening, in the time we were given, this is what we wanted to show you. We are happy if you have questions, if we can discuss this further, if we have research ideas, all this, but for us it's good. Yeah.
I have a question about the suggestion target words. Could you say a little bit more about that before I ask a really stupid question?
So this is the most complicated, the connectivity improvement.
Okay.
That's the
yeah.
one, yeah.
Okay.
So this will give you at the moment, because I have a team of people working on this graph to replace it, because we are making an extra software only for this. This will give you the most connective words, so the most central words in terms of brokerage power within the overall discourse. So Gucci is the most connective one, and then the Kai event, and then Prada, and then Gaga. So these are the words, right? But if I am Fendi,
that's what I was going to say. Is
yeah, I cannot connect to Gucci, or I cannot connect to, well, I could connect to Gucci if I wanted to. I mean, if I'm a small brand and I want kind of copy or associate my image to a well-known brand, that could be a strategy. But Kai, I mean, it's a testimonial of Gucci for the Kai for Gucci event, so I couldn't do that. So in the future, we will replace this with a software that gives you recommendations that are specific to each brand, and also tells you something else. It tells you this is the best strategy that you can implement, but it's computationally, it's a nightmare to do what I'm telling you. So this is the best strategy that you can implement. And within these words, if you use this subset, you will not only improve your connectivity, but you will be sure not to favor your competitors. So it's a much more complicated algorithm.
So I'm wondering, just to kind of transpose this towards gesture, if you have a politician using gesture, you could come up with target gestures. This will improve your brand with gesture, potentially, right?
Yeah.
Or on a team, because we're always looking to, how can we help the team improve?
Yeah.
Well, you could talk about these things, or you could gesture like this, or any number of things to put in there, right?
Yeah, that would be great. Even studying the semantic brand score of gestures and then correlating it with performance of the teams, then you could see which gestures are more effective for performance. I mean, or associated with performance, and then.
And then it could be also, again, it's contextual. If you're working for IBM, if you're working for Microsoft, if you're working for Apple, this is the type of thing. Which then brings me to, you know, that whole scandal in the United States about people getting into schools they write essays and this and that, but they have people writing the essays for them.
Yeah.
Well, if you want to go to Harvard, these are the words that are going to be helpful.
Yeah, that would be cool. Yeah, it's always context dependent. I learned that when I was teaching in Italy to a course in English, it's a program in engineering sciences, and I had a lot of people from abroad, and those that I loved the most, I'm being partial, but the Indian group was the best for me, and they were doing this all the time, and I was repeating my lesson all the time because in Italy this means no, I don't understand. And then I discovered that they were doing this to say, I agree with what you're saying or something like that. So it's really context dependent. Yeah.
But it's really hard to do this. They did like very loosely.
Yeah, I did it bad.
Yeah, it's like really, I can't even repeat it. It's great. Sorry.
Could we take questions from the audience?
So I wanted to give first a round of applause.